Kadri, you there? Okay, so with Diego, okay, things ready to get started.
There, whenever you
So I
are.
think things have been going, from my point of view, pretty great. There's nothing I want to change about the past right now. As far as the conference is concerned, about other things in my life, I've said little tweak a thing here and there. Right. I'm really, really pleased that Kadri, I hadn't really met her in person before, though we've been emailing for a while. It's one of those examples in philosophy where two people that have views that I think are very, very similar, but still when they meet each other, like scream at each other.
Exciting and
Which is why philosophy is so very fun.
They know we started.
Right, so, and anyway, shut up, folks. Quiet down.
Introductions.
Okay, so we're about to start. Anyway, I was saying that Kadri's written a lot about, particularly about free will and about counterfactuals. It's about counterfactuals interacting with a lot, connection with the arguments about free will and so on. And she has very, very interesting.
This conference is about free will.
And she wrote a really interesting book published about 4 or 5 years ago. Longer.
It's quite the longer.
She's from USC, and I think I've said enough.
Thanks. I'll just say 2 things before I start. First, though I actually have a lot to say about free will, I'm not going to be talking about free will in this talk. This talk is about causation, counterfactuals, and laws. I'll be happy to answer questions about free will and what the talk has to do with free will during the Q&A, which should be long. The talk is actually relatively short. And second, I won't actually be giving a talk, at least not physically. It's going to be up there. That's because I co-authored this paper with Terence Tobko. And since some of the points are just slightly complicated, there's a PowerPoint that's animated, and it was just simpler to record me talking over it. Nothing very exciting, but just a few moving parts.
Okay. All right. So I'm playing the video.
I'm a comparativist. I believe that it's often true that in the choice about what we do, that what we do makes a difference to what our future will be. The future is, at least partly, up to us. We have a choice about the future. And this is so even if determinism is true. But we have no choice about the past. The past isn't up to us, not even anymore. We can't change the past in any way. What I want to talk about today is why we can't change the past. Why can we make a causal difference to the future, but not to the past? Let me quickly say that I'm not going to talk about time travel or the so-called paradoxes of time travel. I have things to say about that, but not today. I don't want to talk about time machines. I want to talk about ordinary, everyday causal powers, the ones we take for granted in our ordinary thinking about what we can and can't do. I'm going to argue that we can't cause the past to be different because the past doesn't depend on the present in the way that the present depends on the past. By depends, I mean counterfactual depends. And I'll argue that this is because of the logical asymmetry of the laws of nature. So my argument will look like this. First, I'll argue that the temporal asymmetry of causation arises from the temporal asymmetry of counterfactuals. Then I'll show that this is explained by the structure of the laws of nature. So I'll start with this about causation is counterfactual dependence. Almost always, because it is also what happened. Susie threw a rock from a window. She's a cause of the window breaking because if she hadn't thrown, the window would have broken. Typically, causation and counterfactual dependence go hand in hand. Typically, but not always, They are familiar counterexamples: overdetermination, early preemption, late preemption, trumping. So take the case of overdetermination. Suppose that Billy throws a rock at the same time Susie does. Susie's throw would still be a cause of the windows breaking, but it wouldn't be true that if she hadn't thrown, the window would have broken. Now, cases like these are a real problem for anyone who wants to analyze causation as counterfactual dependence, but they don't need to distract us here, because even in cases like these, there is still a connection between causation and counterfactual dependence. Take the case of overdetermination. Given that Billy was there, the window breaking doesn't depend on Susie's throw. But Billy didn't have to be there. You could take him out of the picture. There is a possible world, a nomologically possible world, a world with our laws where Billy wasn't there. In that world, the window would still be broken. And at that, the window breaking would counterfactually depend on Susie's throw. And the same is true about the other standard cases of causation without counterfactual dependence. In any such case, if there weren't an overdetermining or preempted or trumped cause, then the effect would counterfactually depend on the cause. So even in cases like these, there is this connection between causation and counterfactual dependence. C is a cause of E only if there is a nomologically possible world where C causes E, and E does counterfactually depend on C. Let's call this the causal counterfactual connection. C is a cause of E, and there is always a nomologically possible world where C causes E, and where E wouldn't have happened if C had not happened. Now, I think this connection is necessarily so. This is not a definition of cause. It expresses a necessary condition for causation. And I think that's one we can all agree on, however we understand causation. And that's all I need for my argument. Because if I can show you that the laws of our world don't allow past events to counterfactually depend on future events, I will explain why future events don't cause past events. This is how I propose to explain the temporal asymmetry of causation in terms of the temporal asymmetry of counterfactuals. So let's talk about the temporal asymmetry of counterfactuals. The usual way of expressing this asymmetry is to say that the future depends on the past in a way that the past does not depend on the future. But in exactly what way is that? Is it that we think that there are no true counterfactuals that run from future to past? Some people seem to think that this is true because they think that it's something that David Lewis said. Okay, trackers. Lewis didn't say that. It is obviously false. In fact, there are lots of true backtracking counterfactuals. Here are a couple. JFK had run for office in 1964. He would not have been assassinated in 1963. If Susie were a widow now, she would have been married sometime in the past. These are true backtrackers. But notice something they have in common. They are not just true, they are at least nomologically necessarily true. The one about JFK is true in virtue of the laws of nature. The one about Susie in virtue of the laws of logic. That is why it's natural to express them, not in terms of what would have happened, but in terms of what would have to have happened. So there are lots of nomologically necessary backtracking counterfactuals, but not all counterfactuals are nomologically necessary. Some are contingent. A counterfactual is contingent when it is true in some nomologically possible worlds, but not others. It was contingent counterfactual dependence David Lewis had in mind when he said that there are no true backtrackers. He was talking about counterfactual relations between logically and nomologically distinct events. And his claim was that it is never the case that, given this restriction, some past event counterfactually depends on some present or future event. Now, of course, Lewis himself addressed the issue of temporal asymmetry in his famous paper, Counterfactual Dependence in Time's Error. But I don't think Lewis will be much use to us here, because I think that what Lewis says about asymmetry is muddled from the start. And I mean the very start. These are the first 2 pages of that famous paper. And look what happens here. He begins by saying, today I am typing words on a page. Suppose today were different. Suppose I were typing different words. Then plainly, tomorrow would be different also. Would yesterday also be different? And so how? I do not think there is anything you could say about how yesterday would be that will seem clearly and uncontroversially true. And this seems right. As Lewis says, seldom if ever can we find a clearly true counterfactual about how the past would be different if the present were somehow different. That seems true. If Barry hadn't invited me, I wouldn't be at this conference today. But I would think a bit earlier if I weren't here today. Well, Barry might not have invited me, but it might also have been that he invited me, but I had another commitment or missed a flight or got the flu. If I weren't here today, something about the past would have been different. But there's no saying precisely what that is. I think we should all agree to this. But now look what Lewis goes on to say in the very next sentence. We seem to reason in a way that takes it for granted that the past is counterfactually independent of the present. That is, that even if the present were different, the past would be just as it actually is. No, that is not what his examples show. If we really thought that if the present were different, the past would be as it actually is, then it would be at all puzzling how things would have been different if Lewis hadn't been typing that paper. They would be exactly the same. If I were giving this talk right now, and yesterday, things would have been exactly as they actually were. And if we really assumed the past would not be different, then there are lots and lots of true backtracking counterfactuals, because we would assume that if things were other than they actually are now, things would still be the same as they actually were. So we have 2 different stories here about counterfactual asymmetry. One says that the past is counterfactually fixed and immutable. If the present were different, the past would not be different. The other is that the past is counterfactually indeterminate. It says that if the present were different, the past would be different in some way, but not in any specific way. So what sort of counterfactual asymmetry is Lewis arguing for? Well, in counterfactual dependence times error, he talks as if he's arguing for the fixed past, but that isn't what he means. If I were at this conference today giving this talk, what would be true? Does Lewis really say that the entire history of the world would have been exactly like it actually is up until the minute that I walked in the door or began speaking? Well, no, he doesn't think that. He says that when we evaluate this counterfactual, we imagine that some small exception to the laws of nature, small miracle, stops the talk from happening sometime before. What sort of miracle, we ask? Would angels have come down and taken me up to heaven? Would Zeus have struck me down with thunderbolts? No, these would be big miracles. No, it would be miracles so small, no one would notice. Maybe a neuron misfires in Mary's brain, which decides not to fight. Or I sleep in and miss my plane, or get flu, or somehow fail because the button activates this report. Okay, a small miracle. But which would it be? The neuron sleeping in, the button pressing? Well, Lewis says there is no saying exactly what the miracle would be. It might be one, it might be another, it might be something else. It's, well, indeterminate. So Lewis thinks the past is a means. Well, no. He thinks that before the miracle, all that history, that would be exactly the same. So it's indeterminate back to the miracle. Before that, it's all the same. Okay. But we have to ask Lewis just how long is the indeterminate period, miracle, the time we're talking about? Minutes, days. That's what he suggests in counterfactual dependency times zero when he states analysis 1. But suppose the counterfactual question we are asking is, dinosaurs ruled the earth today, would they be holding philosophy conferences? How far back do you have to go to the antecedent past? A small miracle that deflects the force of an asteroid 65 million years ago? Well, Lewis had to say, it depends on the counterfactual. It's a mess. I think it's a hopeless mess. I think Lewis's account of counterfactuals is wrong. But I won't try to convince you of that today, and I don't think I have to. I don't think my argument depends on any particular counterfactuals, and there is common ground here. I don't think the past is fixed. If the world is deterministic, then if anything were different, something would have to have been different at every moment of time in some way or other. But I think the past is, except for nomologically necessary counterfactually indeterminate. If you are a follower of Lewis, you agree with me about this. It's just that you think it's indeterminate only back to the time of the miracle, because it's indeterminate what the miracle would have been or when it would have happened. The question is, why is it indeterminate? Let's think about counterfactual indeterminacy of it. Forward-looking counterfactuals are often indeterminate. For example, consider the question: if JFK had run for a second term, I don't think this is true. So do I believe that if JFK had run, he would have lost? No, I think that is also false. I think the truth of the matter is that if he had run, he might have won and he might have lost. I think it is counterfactual and indeterminate. I think both of these my statements are true, and I think they are objectively true. That is, in asserting them, I'm not pleading epistemic uncertainty. There are a lot of ways of letting the truth of JFK once again, a lot of possible worlds where the antecedent is counterfactual is true. Some of them he wins, and some he loses. And I think that for every world he wins, there is another one, just as similar to ours, just as proximate to ours in physical space, where he loses. So forward-looking counterfactuals are sometimes indeterminate and sometimes determinate. But backwards counterfactuals, the contingent ones anyway, are always indeterminate. This, I say, is the real temporal asymmetry of counterfactuals. This says that going forward, it is sometimes true of a pair of distinct events, E1 and E2, that if E1 hadn't happened, then E2 would have happened. But going backward, it is never true that if E2 hadn't happened, then E1 wouldn't have happened. Going backwards, it is always, if E2 hadn't happened, then E1 might not have happened, and E1 might still have happened. Susie throws a rock, the window breaks. If Susie hadn't thrown, the window wouldn't have broken. But it isn't true that if the window hadn't broken, she wouldn't have thrown. She might have thrown and missed. If we can explain why there isn't backwards counterfactual dependence, that is, if we can explain why the past is counterfactually determinate, we will have explained why the past is causally dependent on the present. I don't think that this asymmetry is metaphysically necessary. I think it is a contingent fact about our world that holds true because of the structure of our natural laws. Now, this might seem an odd claim, particularly if we suppose that the laws of our world are deterministic. Determinism tells us that the total state of the universe at any given moment determines its state at every other moment in the future and the past. Given the initial state of some system, we can predict its final state. And given its final state, we can retrodict its initial state. Our best theories of the world are deterministic in this sense. As I suppose I don't have to tell anyone here, this includes quantum mechanics. Given the total quantum state of a system at any time, we can infer its quantum state at every other time. In fact, our laws are not just deterministic, they are almost all, what physicists call time reversal invariant, which means that if you change just a few parameters, no laws, you just reverse the velocities, you can run the system backwards. Given that our laws are temporally symmetrical in these ways, how can there be counterfactual asymmetry? I find the answer by noticing that determinism is a claim about total states. If you know the properties of every particle of the universe, you could determine its state at every other moment. If you know the position and momentum of every ball on the billiard table, you can determine their position, momentum, at any other time. But the sort of states that we describe as causes and effects, the particular events that our theories predict and explain, are never total in this sense. It's when we talk about less than total states that asymmetries emerge. So go back to our deterministic billiard table. The 8-ball ends up in the corner pocket. But now, what would things have looked like a second before if the 8-ball hadn't gone into that pocket? Well, that might have come about in many different ways. If the 9-ball had been started a fraction of a second earlier, it would have ended up in that corner pocket instead of the 8-ball. That's a true forward tragic counterfactual. But we can't reason counterfactually backwards to get the same conclusion. It's not true that if the 8-ball hadn't gone to that upper pocket, the 9-ball would have started a fraction of a second earlier. There are lots of different ways it might have come about that the 8-ball didn't go into the upper corner pocket. It might have come about because the 9-ball started a bit earlier, but it also might have come about because the 9-ball was started at a slightly different angle. There is no one way the balls would have to have been a second before if the 8-ball hadn't gone into the corner pocket. The system is nomologically determinate in both temporal directions, but counterfactually determinate only in one. To understand how this can be so, it will help to strip away distractions and look at some system of laws that are much simpler. So here's a very simple system that will help us zero in on what's going on here. Think of this as a miniature universe with its own laws. It consists of just 2 nodes that can be on and off, and it has just one simple law. Obviously, this little world is nomologically deterministic. If you know its state at any time, you know its state at every time. And the world is counterfactually deterministic too. It has true backtrackers. If B were false, A would have been false. Notice though that all the counterfactuals in this world are nomologically necessary. If its future were different, there is only one way the past would have to be. There is another world that is a little more complicated. See if you can guess what its laws are. It's a very simple world, but it does have some contingent counterfactuals. Remember, a counterfactual is contingent when the connection between the antecedent and the consequent depends on other facts. For example, in this situation, if A were on, then C would be on. But this is true only because B is on. We can make the counterfactual false without changing the laws, just by turning off B. Still, in every possible situation, the forward-looking counterfactuals are always true or false. There are true backtrackers in this world too. In this situation, we can see that if C were true, then A and B would have to have been true. This is a nomologically necessary true backtracker. But now what would happen if C were false? I'll give you a second to think about it. The answer is that there is no one answer. It might be that A would have been false, or B, or both. So we have counterfactual indeterminacy going backward, and it's not hard to see why. The reason is that this world is not nomological, deterministic, going backwards. And that's because the logical truth function and is not logically reversible. Knowing a conjunction is false doesn't tell you which conjunct is false. So this world is counterfactually and nomologically determinate going forward, but indeterminate going backward. And notice that the direction isn't there just because we have decided to label one side earlier than the other. It comes from the logical direction of the laws. If we switch that around, then nomological and counterfactual determinism will go in the other direction. So the next question is whether we can have a world that is nomologically deterministic in both temporal directions, but counterfactually deterministic only in one. The answer is yes. Here is an example. Here are its laws. This world is nomologically deterministic in both temporal directions. If you know its state at T2, you can infer its state at T1 and vice versa. Once again, there are true contingent counterfactuals. Here, if A were true, then C would be true. This wouldn't be so if B were false. There are some nomologically necessary forward trackers here too. If A were true, then D would be true. It would have to be. There are true backtracking counterfactuals. If D were true, then A would have to be true. And if C were true, then both A and B would have to have been true. But these backtrackers are nomologically necessary. There aren't any true contingent backtrackers, and we still have counterfactual determinacy going backward. What would happen if C were false? So in this world, we have two-way nomological determinacy, but only one-way counterfactual determinacy. This is just like on our billiard table for the same reason. Nomological and counterfactual indeterminacy can come about if the laws are logically reversible. A function is logically reversible if you can always determine its inputs from its outputs. Mathematicians call these functions non-invertible, set theorists call them non-injective. Negation is logically reversible. If the negation of a sentence is true, you know the sentence is false and vice versa. Conjunction is not reversible. You can get the same output even with different inputs. Mathematical addition is logically irreversible. If you know that x is 3 and y is 2, you know that x plus y is 5. But from the fact that x plus y is 5, you can infer the values of x or y. Some of the laws of nature are logically reversible. Conservation laws are logically reversible. Those laws say that if some property has a value one time, it will have it at another. And the conservation laws support nomological counterfactuals in both temporal directions. So the conservation of momentum tells us that the total momentum of all the known laws is constant. So if it's greater now, it would have been greater earlier. It would have to be greater. But most natural laws are logically irreversible. Certainly all the dynamic laws from F=ma to the time-dependent Schrödinger equation are irreversible. That is, they map a bunch of independent initial magnitudes onto a single condition. And because the same output can be got by different combinations, you can't work backwards from the output to the input. It's that kind of irreversibility that we saw in our billiard table. If you know all the forces acting on a particular billiard ball up until a certain time, you know exactly what its momentum will be at that time. But knowing the momentum of a particular ball at a particular time doesn't allow you to say what forces acted earlier. Once again, if you know the momentum of all the balls on the table now, you can work backwards. The system is globally deterministic in both temporal directions, but it is locally determinate. One, it's that local nomological asymmetry that gives us counterfactual asymmetry between particular events, and that is what gives rise to causal asymmetry. So what are we seeing? Causation requires at least a nomological possibility of contingent counterfactual dependence between events. You get contingent counterfactual dependence from logically asymmetric laws, but you only get it in one temporal direction, which is why contingent counterfactual dependence is temporally asymmetric. It is why backtracking contingent counterfactuals are always false. It's never, this event hadn't happened now, this event wouldn't have happened in the past. It's always, if this event hadn't happened now, this past event might or might not have happened, or it might have been something else. And it is this counterfactual asymmetry which gives us causal asymmetry. It is why no present event is a cause of any past event. And that is why we cannot change the past.
Barry has asked me to handle the questions. That probably means he has a question. So Carla, we'll start with you, then we write down some names. Can I do that? Yeah.
How should I put it? I think I followed the argument. It's a lot of finding interesting. But I have a but. The world, can you put the slide where at the end? Oh, okay. Well, we'll remember it. So that's a case in which you have counterfactual determinism.
All right,
Going
What-
forwards, yeah.
So
Right.
example,
this one,
Yeah, and
Yeah,
this
that
one or the previous one. This one is good enough.
all right,
this world is still
Okay, this world definitely it's an example of the one that you say it's one in which there is nomological determinism. But that's not our world. This is not our world. Period. Or more precisely, this is an approximate description of our world that only holds in a particular world where there is a gradient of entropy. In other words, there is no way to have an ant with deterministic mechanics. So no, there's no ant device that can be constructed with deterministic mechanics. To build the ant device, you need dissipation. Like every engineering needs, you need to dissipate heat. So that world, what that world has in relation to our is that our has something in common with that world to the extent in which we describe ours approximatively, and there is a gradient of entropy which breaks the direction. Otherwise, this could not happen. Okay. Therefore, I agree in a sense with your conclusion that you can trace the time orientation this way simply to this distinction between nomological and factual determinism. But the existence of this, what actually breaks the direction of time is the fact that in our world, that situation it's only permitted. The world is of that kind only to the extent in which we give an approximate description of it, and there is a gradient of entropy. So the roots of that have nothing to do with a priori existence of causation, not the a posteriori possibility of talking about causation in the time-oriented sense in a world where there is a gradient of entropy.
Okay, couple of points. First, I wasn't making any claims in this paper about the direction of time. We argued about that earlier, and I disagree with you about the direction of time, but that wasn't the claim. Second, none of these simple worlds were intended as representations of our world. They were, philosophical thought experiments, artificially simple worlds to make a logical point. And my point was, and I'm glad you agree, that we can find an asymmetry and a direction of, and I didn't even claim there's causation because I don't think counterfactual dependence is sufficient for causation. but it's, well, it's necessary in the sense that I explained what causal counterfactual connection. So my claim, and we can argue much more about that, is that what we may or may not need thermodynamics to explain the direction of time, but that's not what gives you the direction of causation. I'm claiming this gives us the direction of causation.
Okay. I listen to you, but this, as far as this is concerned, as a physicist, causation is totally irrelevant to the description of microscopic. There's no causation. There's no time-oriented causation for the physicist. In the sense
What about
of
billiard
Russell, in the
balls?
sense-
When billiard balls collide, they don't cause each
No,
other to move.
There are relation to the initial state and the final state, which is time. So there's no time-oriented position. There's nothing that in causation breaks the direction of time. What in causation comes in to break the direction of time is exactly.
Again, you're bringing time into it. I'm saying that our ordinary, everyday, empirically informed beliefs about causation, and if you like, I'll just talk about macro causation, can be explained in terms of this, the direction of contingent counterfactuals. And I gave examples to show that these turn up at our world with billiard balls and extraordinary counterfactuals about people. That's my claim. I mean, I am not, I could talk about your talk and whether entropy gives the direction of time, but I don't think I should talk about that right now.
Okay, so we're going to go to 11:25. That gives us a decent amount of time. And I have David, Phil, Barry, Janan. Maybe,
There's a Zoom question also.
there's questions online.
Jacob, yeah.
Okay, so let's go to David, and then you can tell me who's online.
Right, so I guess I'm pressing a point here similar to what Carlo was trying to press. But maybe in a slightly different way. By the way, just one purely technical point. I don't think it's relevant to your argument at all. But what you said about the determinism of quantum mechanics seems really, really misleading to me. But like I said, I don't think that was relevant to the details of your argument. Maybe we can talk about that another time. But anyway, I'm just really puzzled about what you're saying about the logical structure of the laws. First of all, Carlo is right. We've known, it was pointed out at least as early as 100 years ago by Russell that notions like cause don't make any appearance in the way we formulate the fundamental laws of nature in physical theories in the past 300 years or so. And in the case, and I'm struggling to see what this logical asymmetry is supposed to be. Take the F equals MA case. I'm not sure I'm seeing where the symmetry is. If I know, I'm going to have to use terminology here about the direction of time because I don't know how else to pose the question. Maybe you can help me with that. If I know the force on a certain material body, I know its acceleration as I watch it in the film strip being played forwards, and I know its acceleration as I watch it in the film strip being played backwards. As a matter of fact, its acceleration is identical in both of those. I'm not seeing any logical asymmetry.
Can I answer that?
Sure.
Okay, so first of all, this Russell's argument and the claim that causation doesn't show up in the laws, of course not. I think it's a misnomer to talk about causal laws. When we talk about special sciences, we're really talking about causal generalizations over individual causal facts. So that's the first point. I wasn't claiming it. And the second point, I very briefly went over the time reversal invariance thing, but that's not the same as inferring the claim about determinism, being able to infer backwards. And it's also not how we evaluate a backwards counterfactual. We don't say if the 8-ball hadn't been in the upper left corner, it would have been exactly where it was earlier. We don't evaluate the backtracking.
No, you're pointing correctly
okay.
to a habit, to a linguistic habit.
I don't think it's a linguistic
Okay,
habit.
that's what I want to explain.
Okay.
There is, here are some facts. Like you said, you take total states of the world, okay? No asymmetry arises in something like Newtonian mechanics, okay? This is a contrast with your and circuits and so on. You take total states of the world, 0 asymmetries arise. What you can infer about here from there is exactly what you can infer about there.
Right.
Good. You said that's true, but there's some local sense in which the symmetry is broken. And then you wrote down F equals MA and the Schrodinger equation. I'm trying to understand what's going on there. My instinctual reaction would be, no, there's 0 asymmetry on this local level too, so I must be misunderstanding something. So let's focus on F equals MA, which was one of the things on your list of things, which was you were calling locally asymmetry.
Can we start with the simpler case? Because I actually had the slide on the board of the billiard ball table. We have the 2 billiard balls collide, and then they go off into the opposite points from where they would have gone had they not collided.
No, that's a much more complicated case. That's what's really contentious. F
But
equals
that's
MA
the one
is
that
what-
makes my point.
F equals MA is what's going on at one instant when they collide.
Mhm.
Claim. So let's just see if we can establish this. Claim. There's 0 such asymmetry in F equals MA. None.
If we're just looking at the law and we're talking about, the force at a time and the acceleration at the time, then yes. But if
Doesn't
we're
that
looking,
contradict what you said?
no, I'm just saying there are, I'm saying that if we have something of a certain mass accelerating at a certain rate, then it was thrown of a certain force, or it was thrown from a greater height or whatever. I'm saying that there are different ways in which what I've been calling the final state, and you guys are objecting because you think I'm bringing in time, but that we reason differently in one direction and from another.
There's no doubt that as a sociological observation that we reason differently. I take it the interesting question is why we're right to do so, or what it is that we're putting our finger on about the way the world really is when we do so. And I understood you to be tracing this back to some logical asymmetry in the laws themselves, like F equals MA. And I'm saying I don't see any such asymmetry there. So that must not be the right explanation of why we talk in the way we do. And I, of course, agree with you that we talk.
Well, if you're always going to get me on the physics, but if I just put it as an abstract point, F equals mass times acceleration, that's a function that's like multiplication, which is an irreversible function. So while you can calculate individual force or individual acceleration, either way in different cases. It's still.
But that inputs, so you're taking a parallel between inputs and outputs and earlier and later.
Mhm.
That seems misleading to me here, but look, I don't.
We
wanna-
could call it left and right. I was specifically saying. I was specifically saying that it doesn't have to be earlier and later. My claim is that it's a contingent fact that things line up this way at our world, mostly in one direction. They could line up differently. I think it's a virtue of my account that it doesn't rule out the possibility of backwards causation. And I'll stop.
Okay, I really enjoyed the diagrams you made. And I'd like for you to repeat what you said about injective functions, because I'm a student of mathematics, and bijective functions, surjective functions, and injective functions are fundamental. And tell me more about, you said something. And I think I can add to your point on what F equals MA means, if you tell me what you.
That's, here I'm going to plead co-author who insisted on putting that in.
Okay, well,
So
let me
you can
explain, let me explain to you. So F equals MA, if we go into a simple one-dimensional case, M and A are both real numbers. So what this is this is a function from the Cartesian product of the real numbers and itself to just one copy of the real numbers. And if you are given in this simple one-dimensional case M, and you are given the output, you can recover A. And if you are given A and you are given the output, you can recover M. And that's it. If you are given an output, though, you can recover an entire set of possible inputs. And if you understand what a bijective function is, an injective function, and a surjective function, you can make your point much more precise.
Thank you. Tell my co-author.
Barry.
So the point that you're discussing with David is really essential to the whole discussion, because there's an explanation of the asymmetry of counterfactuals, which involves something about the initial conditions, low entropy. And your account says, no, it doesn't have to do with that. It has to do with something about the dynamic laws. But you pointed to something that just doesn't exist about the dynamic. The dynamical laws of classical mechanics are completely time reversible. I don't know where you got
Time
this.
reversibility is not the point, as I explained. We're talking about a logical asymmetry. It's not time reversibility at all.
But let's see, but we want to know why it is that the counterfactuals are not time reversible. Why there's a temporal asymmetry?
Right.
in
But
counterfactuals.
nobody thinks the counterfactuals, that would be crazy. If I were giving this talk right now, I would still be at home as I actually am. I mean, we don't reverse, we don't literally go backwards. And since
Well, I agree with that. We want to know why.
Yeah.
What is it about our world that underlies that?
I gave an account, and I know you have a different.
But your account was in terms of
But since
something
you're
that doesn't
talking about the
exist.
direction of time, I don't get why increase of entropy is supposed to explain the direction of time. Suppose
I understand that.
started to decrease, would we think time is running backwards? No, we would think the world is not
Wrong.
the way we thought
It
it
depends
was.
exactly how it would decrease, but yes, it would increase globally. Time would be running backwards in a particular way. That's right. Now, I understand that you don't get it. There is a
For
whole
time to
account.
actually run
David has a
backwards.
beautiful account of how that works in Stoke Time Chance. So it is worth looking at.
Excuse
But I
me.
just wanted to bring out that this is a big issue then between us.
So for time, maybe you don't mean what you seem to mean by time to run backwards. We can make sense. Well, I think Peter has some papers about actually time reversing.
I can't see because Diego's in the way.
I do not.
Time might run backwards if it were a sort of a closed curve and we ended up,
I don't think
back
time
at
runs
this-
anywhere.
Well,
I am using
somebody
it
might have said that.
metaphorically,
So
okay?
don't do it.
If time were a closed loop and somehow or other we were at this, we wouldn't be at this conference again, but there would be time literally running backward, would be returning to the same moment of time. I know you don't mean that by, I'm not sure what you mean.
Who, me?
I'm not looking at you, Peter, I'm looking at
What I mean is this, that the explanation for all the temporal asymmetries in our universe has to do with the low entropy of the universe. That's
Okay,
what I
now-
mean.
now,
I'll argue for that.
That's
so why that's so.
different. Paul Horwich, a long time ago, the first time I started to think about time, wrote a book called Asymmetries in Time, in which he denied that time has any direction. It's just this four-dimensional block. Nevertheless, there are all sorts of interesting asymmetries of time, and some might explain
Does that
others.
conflict? Do you
No.
think you're conflicting with anything I just said?
Mhm.
Do you think you're in conflict with anything I just said?
I guess I'm trying to understand. What
So
you
I don't
said.
think
It
time
might
is it.
be
I agree
true.
with Horwich. Time
Yeah.
has no
So
direction.
listen, it might be true that the time of our universe has this really interesting asymmetry that matters a lot to us because we love to live forever, right? We love to not decay and die. So I'm not denying that time is asymmetric in that way.
The
I
temporal
am
process
saying
is-
that time is also asymmetric in a way that really super duper matters to us because it matters to our free will, that there really is causation and it runs forward, except maybe for weird cases of time travel. And that's what causation turned out to be possible. So that's my claim. It's actually consistent with yours.
I'm really not sure which part of it I agree. Here's the place where there was an interesting disagreement. There is an explanation that's now pretty widespread about why it is that, for example, we can influence the future, but not the past in any interesting way. And why it is that we have lots more traces or records about things that are past in the future. But this is, I think, is what gives content to why one direction is the future and what's the past. Because these are the
So
phenomena.
which parts of my argument were you disagreeing with?
What?
Do you think that counterfactuals are not temporally asymmetric?
No, he doesn't. think
No.
that. He was disagreeing with with.
I know, I
what
mean the
you
micro
proposed
ones. I mean the ones we don't notice.
I don't think we ever even
proposed.
think about those, about the whole universe as a whole. We only.
I'm not talking about the universe as a whole. I'm just talking about, if I weren't talking to you right now, what would have been the case earlier?
The micro history of the universe would have been different earlier, but in no
Would it
particular
have been
way.
different in
But in no
specific
particular way.
ways, the specific ways
No.
that? So then you're agreeing.
I agree with that part of it.
Yeah.
Here's the part I'm disagreeing with, and which I think is really important, super significant. There's the question of where do the asymmetries, the temporal asymmetries all around us come from, given that the fundamental dynamic laws are temporally symmetric. Now,
Now you're talking about time reversal invariance, which is not what I was talking about.
here's what I'm talking about. All around us are temporal asymmetries, yes? We can influence the future, but not the past in any interesting way.
Sorry, when you use the word influence, that's a separate claim. I need to know what you mean by it. You
Here's what I mean.
Cause?
No decision I make now will make any kind of probabilistic difference to anything that happened in the past.
You're going to be giving your paper about, this, so why don't we
Yes,
talk
no,
about this later? Because I
Okay,
know
we
you have a theory of
could do that. I just wanted to
counterfactuals.
bring out where there's essential disagreement,
I think
because that should be something that people should appreciate. You were trying to attribute this very interesting fundamental feature of macro universe that philosophers who have been interested in, some have been for a very long time, the temporal asymmetries all around us. One explanation, which is what I think David and Carlo were talking about, is in terms of the increase in entropy over time. We're connected to that.
Again, please, I wasn't trying to give a general account of temporal asymmetry. I wasn't talking about the direction of time. I asked a specific question about why is it that we think we cannot change the past, where change means what we ordinarily think it means. Why can't we causally affect, make a difference?
I'm talking
to
about
the
that
past?
too,
And I keep
because we
it
both think causes and counterfactuals are supposed to connect.
Pardon me?
We both think counterfactuals and causes are supposed to connect.
Yes.
So Barry put me in charge of this session because
So you can tell me to shut up.
he knew whoever was in charge was going to be steamrolled over by everyone else. So Carla would like to get in on this point, but I have Janan, Jacob, Carolina, and Jessica as well, and
Carlo can say his phrase.
Can you unmute?
Just one phrase.
Okay.
It seems to me that disagreement is only.
Can you unmute?
It's only.
go ahead, Carla.
Seems to me that disagreement is only the fact that what for you is an explanation, for a lot of people here is what it has to be explained. That would seem to is what needs an explanation.
I think I'm gonna
Jeanette.
agree with like everything everyone said, but maybe put it in slightly more friendly way. I mean, not that it wasn't unfriendly, I mean, I'm trying to add yourself to what everybody else is saying.
You've heard about rice.
Everybody correct me if I'm wrong. But I think, like, you're latching on to the logical structure of the way you reason from the past to the future. And I thought you were giving, a really nice schematic representation. And the interest of the physics is why in physical terms does that structure arise, given the following reasons, given the fundamental metaphysical laws, at which at least in the classical are primary.
Again, time reversibility is
Wait, look, you're
not.
talking about reversibility. Reversibility is reversibility in time.
No, the claim was about the logical asymmetry, which I clearly explained is different
But the
from.
sense in which that structure gets realized in our universe is reasoning about the past and reasoning about the future.
Yes, but we reason forwards, and that's where Lewis was right. It is very hard. If you ask any counterfactual about,
I'm
you
not.
know, the
disagreeing.
billiard balls, how might the billiard balls have ended up differently? You have to sort of try various things going
Everybody
forwards.
Agreed.
Yes, so-
Agreed. What I'm wondering, and this is what I think Carlo and David and Barry are saying, yes, we all agree on that. And the question is, how does that arise in the universe with fundamental laws of time symmetry? And here's an account, and that connects what you said, I think, with the way that David explains. this.
But you're-
Let's just think about propositions. One of the things that you said is we get that kind of structure where we get contingently true counterfactuals, where the counterfactual depends on other things that need to be in place. And those things might or might not be in ways that are unspecified when you raise the counterfactual. Here's how that arises in a universe with an entropic gradient at one end. One of the things that we do when we assess a counterfactual is, and I'm going to put this in David's terms, though I think that you can, you don't need this much specificity, but you see the contours of the explanation, the way that it connects to the entropic gradient. When we're reasoning about a counterfactual, first it has to be macroscopic, which is what this everyday structure, where I agree with you, this everyday structure is commonly realized. Why does it arise in physics? Because when we're assessing a counterfactual, looking forward, among the things that we hold fixed are present surveyable macro state of the world and the past hypothesis, and those two things together will fix all relevant auxiliary assumptions.
That's one theory of counterfactuals, and I disagree, but we could have a very long argument about that. I've been arguing with Barry about
Okay,
that
but
for
let
2
me
years.
finish just so that you see the
But
connection.
can I
between
just
what
ask you,
you're saying.
was there anything in the billiard ball case or a simpler billiard, you know, just sort of slightly fictionalize it to a world without thermodynamics, simply classical mechanics, billiard
So
balls?
wait, what do you
bouncing?
ask?
You keep agreeing with me about the counterfactuals and saying the question is how you explain them, and then all three of you start to talk about entropy.
Can I ask you?
Yeah.
So you don't think that there is a classical world, that is a world obeying fundamental classical laws in which you don't have the kind of counterfactual dependence you're talking?
Say again?
You don't think that there's a world obeying the classical laws where you don't have the kind of counterfactual dependence in one direction and not in the other, logically irreversible counterfactual. You don't think there is such a world that obeys the classical laws?
No, it depends.
It depends on what.
That's a good way.
No, things could, you're right, things could be pointing in different directions.
Okay,
We
good.
might have a world,
Let me
we might have an unfortunate world where there's backwards causation.
Well, so the physicists are interested in what are the conditions, additional conditions that you need to have in place, in addition to the microphysical laws, to realize the very kind of counterfactual dependence in the future direction and not the past.
Yeah,
That's what the past hypothesis. You might disagree.
I understand that, I understand
But
that.
wait, you might disagree with the details of the explanation, but to think it's irrelevant and to think that your
I
explanation.
didn't say it was irrelevant. To quote Peter earlier on, I don't think it's obvious that I'm right and you're wrong. I was
But
making,
surely you want to be able to connect.
when I
Well,
finish,
people here are trying to.
But
yeah,
yeah, a lot of this conference has been dominated, I guess there are more of you, by the physicists. And you're all for, you know, this is what our world is really like, and we have to take physics seriously, and I have nothing against that. But as philosophers, we can also think in terms of metaphysical possibilities, and we can certainly understand causation at worlds different from our own. So my little super simple hypothetical worlds were intended to show that we can have those kinds of structures, and those worlds, and maybe also our world.
But the
maybe-
sense in which this was a friendly was precisely trying to connect what you're doing, which I understand, the kinds of questions that people here are asking, the relevance of their explanation to understand why in our world, given that our world is one with that, we get that structure. So I don't think you're talking at as much at odds as you.
Okay.
Okay, let's go to Jacob, where we have total control over that.
Thank you. I just want, oh, I'm getting some feedback. Hold on.
On our end, you sound good.
Can you still hear me?
Yes.
Yeah,
Okay, yeah, something's going weird with my audio. Hold on.
yeah, Jacob, you're on.
Okay,
Microphone here.
There you go.
can you still hear me?
Yes.
Yeah,
Okay, good. I fixed it. All right. Sorry. Sorry about that. I wanted to say, first of all, I really enjoyed your talk. And I want to thank some of the questioners who came before me, in particular, David, who asked one of my questions already. So I have fewer questions now. One of my questions is just a clarificatory question. So you showed that diagram before. I don't know if you can pull it back up again, but it was your last circuit diagram. Can you show that again? Is that possible?
I would have to share it. Hold on.
Try. I'm
I
not.
was just confused about it. So
All right.
Yeah, that's it.
Yes, but Jacob also has to say it. Okay, so what
yeah, this is it. Yes, right. Good.
the billiard ball?
No, the circuit diagram.
The circuit diagram. I'm sorry.
The last one that was nomologically deterministic, but counterfactually, yeah.
This one.
No, farther
Go
Further.
forward.
in the future.
There, that one.
Oh, this one.
No.
No, keep going.
This
There,
one.
there.
Yes, that's it. Good. Thank you so much. Yes, that's exactly right. This
Okay.
talk is not time reversible. Okay, so the point. So if you could just clarify this. So you're saying is that this is a dynamics in which if we know the total initial state, then we can deterministically infer the final state and vice versa, as long as we know total states. But then you said if we only know that C is activated, then we can't infer the other things. Do I have that right?
No, if looking at it like that, if C were on, then A and B would both have to be on.
If C were not on, we wouldn't be able to.
No, if it were on. Well, I'm just looking at the diagram as it is now, where it is not on. It would be the other way around if A and B were on.
There was a point in the animation when you there were a bunch of question marks. Am I remembering correctly?
Oh, you need to.
Is that farther ahead in the talk? Sorry.
Yeah,
Question marks. Yeah. Hold on. Oh no. There are question marks.
No. Farther ahead. It's the.
you have to keep going.
There are question marks here also.
No. It's that diagram, but a little bit farther ahead. You could yes.
It all
Farther.
turns black at
That
some
one,
point.
that one.
Yes,
I
yes,
believe,
but
yes.
it turns
There's
black at some point.
Yes,
One farther along where just slightly.
Okay. All right. Yeah.
Yes, I see it. It's in a little yeah.
Yeah, but
That one.
hold on. All right.
Counterfactual.
Hold on.
What would happen if C were false?
All right.
Okay, that's it. Pause. Good. Okay.
Okay.
So if all we know is that C is false, then we don't know for certain what the past state was. We also don't know certain details about the current state by assumption. We're assuming all we know about the final state is that C is false, and then we can't determine what is the case.
We know, we can know D and E. The point is, I'll go back again, show the slide before. It's easier to explain.
So
They were on, no, the same one, but just before.
just
Yeah,
before.
it's false. Yes.
I'm sorry.
Here.
I think-
Sorry.
I think this like
It's an example.
this video is a little glitchy. All right.
Yeah.
Or
That one, that's just stay there.
Right.
No, we know what the world is like at present.
Yes.
So we're asking if C were on, or if C were true, to put it in terms of the conjunction.
Yeah.
It's not that one. If C were on, then A and B would be on. You were
Yes.
asking about the one where C is already on. So you have to go forward a tiny bit more.
Is white on or is black on?
If C is on, then
This one,
everything is
okay.
on.
Is
Now-
on, what is, which two on and off? Black is on and white is off, or vice versa?
Everything is on.
Okay, black is on, okay.
Black
see it.
means on.
Yeah.
Okay, yeah, so my question was, you seem to indicate that if the only information we had about the final state was that C was off, which I'm taking to be white, and that's the only information we have about the final state, then we cannot infer what the initial state was. That's a correct statement.
Well,
Yeah.
yes, of course.
Okay, yeah,
I was thinking of the counterfactual, but yes, of course. 'cause it
right,
could
right,
be.
you can phrase it as a counterfactual, right. We can't, from C being off, we can't infer precisely, exactly.
Yeah.
But I guess where I'm confused is, if I say only knew that A was off and knew nothing else about the initial state, would I be able to deduce the final state?
You'd be able to deduce,
I know that D was, I mean, if A is off, I know that D was off, but I wouldn't know anything about C or E, right? I guess where I'm confused is, it seemed like you were indicating that there was something special about the reverse time direction, because although everything is deterministic if we know total states, somehow there's something going wrong when we try to infer backward, because if we only have local information about C, we can't go backward. But it seems like in this diagram, if you only have local information about the initial state, you can't go forward. Am I misunderstanding?
sorry, I'm blanking out now. Too little sleep.
I could just be misunderstanding. So I mean, if anyone else wants to, I'm sorry. I just got confused about this.
I think he's right. So, so let us move on. We just have a few minutes left to Caroline.
Oh, so this isn't a different thing.
Oh.
Okay.
Altogether. So the first part where you said, well, even if counterfactual not required for causation, some variant on that is. I was wondering why exactly you thought that. So you thought it was pretty obvious that you could separate the two causes and Billy and Susie. In that case, I can see that. But are you making certain assumptions about things like macro and micro causation? So imagine that you believe that the rock is a cause, but also the atoms composing the rock are a cause, and the rock can be made up in different ways, by different atoms, slightly different atoms arranged in slightly different ways. So I don't see how you can separate the two causes in the same kind of way. So imagine that you take away the actual physical realizer, microphysical realizer, but the counterfactual, if that microphysical
So-
realizer.
Yeah, I don't view, that's not a case of overdetermination as it's standardly construed.
Right.
They're not nomologically independent of each other.
That's right. That's exactly what I was trying to get
Right,
at.
so, so now what is the issue? I mean, I know there's problems about causal competition and which is really the cause, et cetera.
Yeah.
But I'm not, I do have a theory of causation, but I wasn't appealing to it here.
So I took it that the idea is that you wanted to get to that counterfactual, because then you are going to appeal to counterfactuals to give your story about why we can't change the past. So it was really important that we first got to that counterfactual. If we can't even get to the counterfactual.
Well, I think both counterfactuals could be true in that situation. Why wouldn't they be?
I thought So what I had in mind is that if you couldn't really separate the two poles, if they're non-logically connected, then that counterfactual is never going to be true. So without that physical realizer, you would still have had the same outcome. Because
So-
there could have been a different physical realizer, but
I-
maybe you just didn't.
I talked about events here as shorthand. I actually don't think causation is a relation between events, and I think a lot of the troubles come from that. I think it's a relation between facts. So I know the problem you're talking about, but I don't think it's a problem.
That's right, so that was my question, whether you were making additional assumptions about causation and the relation with counterfactuals.
And we have 3 minutes left, and Jessica has been waiting, and Diego should get a chance to ask a question because he's had to deal with the video.
I
So we
can
can start
ask
late
her.
for that.
Okay, so, well, let's let them both in.
Yeah.
So Jessica, go ahead.
Okay, great. First, I just want to make sure I understand your view, what you were trying to do. Because I think it's kind of cool, practicing concerns about like analysis. So you want to say counterfactual dependence isn't sufficient, but it's necessary for causation, right? And you also want to make sense.
Well, not actual counterfactual dependence, but counterfactual dependent at some nomologically possible,
Got it.
very weak condition.
Okay, cool. And you also want to make sense of why we can causally affect the future, but we can't causally affect the past. So you're taking for granted that kind of past future line. Just want to make sense of that.
Yeah.
And your suggestion is, let's look to the logical structure of the laws. So if this is the part I want to make sure I understand, because I think this is the cool idea. If the laws are such that there are different ways to arrive at the same local state,
Yes,
right? Then we can make sense of this, because if so, there's going to be many different ways to bring about a counterfactual antecedent. So the associated counterfactual will turn out to be indeterminate.
yes,
And so we can't use counterfactual dependence to input into our account of causation. So, that's why we can't causally affect the past. Because if the law, but the crucial condition, it seems to me, is that the laws have to be such that there's different ways to bring about a given counterfactual antecedent. So for example, in the case of a force, if the force had been different, well, what would have happened? Well, there's different ways to bring about any given force, you
yes.
might think, in classical mechanics or otherwise, right? So we're not talking about like just actually how it was, you're talking about the counterfactual antecedent and how it might have been brought about. If the laws are such that you could bring about.
That's exactly it. Thank you.
So I think that is cool. So then my question is, what about in worlds where the forward counterfactuals are also indeterminate? For example, if
The which counterfactuals?
the forward looking.
Oh, yeah, if they all are, I gave
like-
example, I think lots are, and when people sort of, dismiss counterfactuals on the grounds that they don't tell us anything, they're the ones with those, if JFK had run again, but you're asking where there just are no.
I'm allowing that, okay, yeah, if you have a counterfactual indeterminacy, then, you don't get causal, ability to impact, right? But then when we all, if like quantum indeterminacy is such that we can in fact, our counterfactuals might actually end up being determinate going forward.
Okay, good,
As
sorry,
well as
thank you.
backwards, then what?
The question is,
Then I think we would have to say that what Barry wants to say anyway, that the counterfactuals are probabilistic, and you'd run it that way, I guess. They really are objective probabilities.
Okay.
Then
Cool.
it wouldn't just be the mites, though, it would be, there would be some number such that it's less. Thank you.
Yeah.
Diego, we're gonna go a little bit late and then
All
we'll
right,
take a 5-minute break.
It was actually like a clarificatory question. It would be good. No, yeah, I will also do this since I'm the one in charge. All right, so like I mean, so you talk about like irreversibility, and there's this point about irreversibility that like it's it's hard to understand for me in which sense. For example, of course, negation is like irreversible in one sense, in which like if you look at the function which represents could be a function from propositions to propositions or from truth values to truth values. It's non-invertible. For example, that's what I understand from negation being irreversible, right? And then like, it's hard for me to understand, for example, what you mean by saying that a law is logically reversible, because like, well, I mean, for example, like a law for me is just a set of sentences. How is that like, which function should I be thinking that's non-invertible here, or you know?
If you're thinking of a law as a set of sentences, then it's easy, think of it as like conjunction.
Right. All right, conjunction is right. Yeah,
You know
but
the
there's a
values
sense.
of A and B.
There's a
you
sense in which I do associate a function with conjunction, right? Which is a function that takes two propositions and gives you like one.
So if you know
right.
that P and Q are both true, you know that conjunction is true. If you know that P is true and Q is false. But if you know that the conjunction is false, you don't know if P is false,
Right,
Q
right.
is false. or both
So
false.
there's like the
That's it.
relata are like the truth values, and there's a function that takes truth values to truth values, and that's non-invertible. So like when I talk about laws, the easiest way in which I like sort of try to understand this is just like there are laws like take you from one situation or to another situation or something like that, right? And the fact that they're non-invertible, non-invertible, like because I do think everything as a function, means that sometimes they take you from different situations to the same situation, right? So the final situation is such that you don't know which one it came from.
Right.
And so like I had like this little point, which is so yeah, you say, for example, you put some laws that are reversible and irreversible. But for me, what takes you from some situation to another situation is not a single law, but it's a set of laws. So you could put FMA or something, and that law, like, you could add some other laws such that you can always recover the initial state to F
Yes.
equals MA, right? So it's not like,
I did not, that was precisely the point. If you have the total state, you can go in either direction.
right, but it's like, it's not one law which is like irreversible, but like a set of laws, because you could always add to each set of laws, you always could add extra laws such that you can, like, this is a like funny diagram. I could actually use the whiteboard, maybe not. But yeah, let's say you have world 1 at time 1 and world 2 at time 2 or whatever, or forget about times, world 1 or world 2 or state 1 and state 2. And the law is irreversible because like takes those states and produces a single state. And state 1 and state 2 are different, and then like produces a single state. And that's why it's irreversible, whatever. But then like you could add something like, but the thing is that like it's not a single law, it's just a set of laws or whatever. And then you have to know what each law does to see what the final state is going to be. So if you add laws to that, you can make sets of laws which are invertible, non-invertible in that sense in which I explained. You can make them invertible, but just by adding extra laws, right?
So I think you're again saying that determinism is a claim about total states when you're using all the laws and all the.
Yeah, it's like a total claim. You agree with that?
Yes.
Right,
Yes,
okay,
I was
fine.
trying to show
That's
how.
perfect.
Okay.
Okay, I'm opening all the doors to try to get some cooler air in here and see if I can talk this.
There's a lot of heat going on.
Yeah, that's right. And you put me in charge, of course.
You're in charge of me too.
Yeah. So 5 minutes and then we'll come back for Barry, right, Barry? Okay.
Thank you. I was.
Right, yeah, it was like this sort of thing, this diagram that I want to, like this is like the effect of the laws in a given amount of time, just like epsilon, whatever. And that's like the fact that it's not reversible, it's just like this, and it was reversal. Like, so the thing is that L is a set of laws, you can add Like,
Yes, that was what this oversimple thing was
Right.
trying to show, and I messed up that question, I just went out there.
Well,
But
Right.
the idea is, you know, these are like the conservation funds.
right.
Have this, and that's what switches this around, you know, here we don't have the information, here we.
So.
Okay, great, great, yeah, that was.
Right, but then, so the interesting question.
And thank you for all the technical.
Is that, you know, what's the
Fairly complicated.
Yeah,
Going back to
it's,
the.
it's harder and
Especially because you don't know the talk, but I really do.
Yes, sorry, to the top, would you have a infinitely receding, but just continuously? Okay, sure, you know more than me. You need a gradient. You can have that even if you have an infinite.
Yeah.
But can you have
Jessica,
the gradient even if you have an infinite?
Yeah, I mean, you only gave them a.
Right.
Thank you for actually saying. the
So
meaning.
whatever, yeah, we can segment reality.
What?
But as long as it's not gonna
Thank
read.
you. Because you know, the always as Paul Dorff said, oh no, that was afterwards at lunch, you were his talk. We were talking about it, and he said, the problem is that, you know, the physics guys say a bunch of stuff, but then you're wrong.
If it's relevant.
Yes,
And so as well, I mean, to put it, sorry, just a way.
for the purpose of this talk, I actually think it's, yeah, I know.
Right.
But it's
No, that's like, that's not so.
I know, it's just because they all, I know, I've looked at them.
But she wasn't really addressing.
Yeah.
So the first part of it was very.
Well, it's so, it doesn't explain how we actually use it, you know, how do we actually help any of them, and oh, wow, it's not. Our job. Seriously.
Yeah. Tony Gardis also suggested in addition that with respect to the question
It's time.
he also suggested.
There's all kinds of.
Oh, good, yeah.
Suggestion.
But you see,
As
for-
it was
Nothing. I know. They just. There's not an event, but it's the event that hasn't happened to you. I know. Yeah, I know.
You can roll back, if it happened, you could roll it back.
Yeah.
Right, right?
Could have said that.
Anyway.
It would have been nice to have ended with yours, but in the end, Dave just took him a long time to say, and I kept it. He had told he does philosophy and that, something terrible and complicated.
There's three. In order to preserve.
Basically saying, time reversal event is. We don't have it there. If the laws are.
Yeah.
About this, you know, course, like,
But we're just giving. That's
that was my last question.
Right.
All the possible. Right, but there's also even simpler questions in terms of functions, right? Yeah, so it's like there's a non-reversible and then so like the thing is this, you must think as the laws, not as functions, but as functions of states.
So going from one state to another, what are the odds? And going from
So you just like, if you have a state and then you like ask what's the set of laws,
And that would be.
evidence, hey, whatever, and that takes you to another state, given a certain amount of time, right? So like this like this is like state time it takes you to like, well, even the loss, even the amount of time, and abstract time, yeah, this is so like the fact that they're non-invertible just states. Right? Yeah, it's natural as that. So the thing is that like the point that I want to make is not that a law is reversible. It's a set, because you could have L, which is your set of laws. Or you could have like L plus some other laws and just literally turn it into an injector. So which way? Suppose that you have been done or whatever, and that makes like a third, like the last law, which is like, oh, by the way, God exists, and he just like writes down everything that happens. So he has a big list. So the list here is different than the list here because like it includes like what happens. Yeah, I know, like that's
nice.
yeah.
I think that's right.
Okay, so she's not.
I don't know, I can't remember what it was. I like, this is what I was trying to get at.
Right, yeah.
There would be different like initial conditions that brought about this.
Because like you could always take like one inverted set of laws and then you like a law.
Determine it, and the laws have to. And you know, never mind.
No, I think like that it's not single law.
There is only one law.
If there was only one law.
There is only one.
Yeah, so there's lots of ways to get it.
Oh, but you also have to, because there's like, so you have to say that, and you also have to say, and there are no more laws. You know, and that's important.
We're talking about a fact. So she wanted to
Then I don't
derive
understand
the
why.
asymmetry, the macroscopic asymmetry from some sort of asymmetry. And
In this world, you know,
it wasn't
there's so many talks about how, given that you're talking about a fact. Okay, let's assume this happens. It's like how you guys.
and even if they were like in general,
Or, yeah. I mean,
The laws are from plastic forward that.
you can make sure by
so it's actually not super.
But if you don't.
What she grants
Grants that.
Unless you can like,
oh, yes.
Are not like that. Yeah. But she doesn't, she's not trying to necessarily.
She's trying to
evaluate.
Yeah, right.
Yeah.
So she's thinking that the dynamics is like macroscopic. Dynamics. And these really are temporary.
No, I agree with that, but I mean.
And that's where.
You see her point though, it's not, I mean, it's not practically, as I thought it says. No, it does provide a kind of way. If you had.
Yeah, I understand. It's supposed to
A
be.
lot of situations that are these days.
It's consistent with what is called the macroscopic that would be microscopic. Different microscopic. She would be, she's probably that. I have no idea. But
No, this is fine. They're just.
Then I think it's.
I mean, if you can explain it. Yeah.
I mean, after the trust.
All right, yeah. Good.
I know. I didn't think of that.
Yes, I have your slides. You sent them to me.
Yeah, so I hope they're the right thing.
You sent them to me yesterday, right? So they're here.
I want you to say something quickly, David.
Is there a
No, that was, it was taken.
Yeah. Yeah, good, good.
And there's other stuff, you know.
That's
you
right,
have to walk
that's
this.
right.
I know it's like-
That's right.
Yeah.
Right.
Yeah.
I'm actually Belgian, but I'm working in Sweden.
Right.
But I go around looking at Swedish.
B-R-A-N.
How's it going? Good. Good.
Well, it's better. This will be some pretty chaotic discussion. Some pretty chaotic minutes of discussion, to be honest. But yeah, I guess this will be a little simpler. I hope.
What's that?
I hope this is a little less chaotic.
Yeah, I think so too.
Yeah. All right. I'm sharing, yeah, I'm sharing screen.
Okay, let's begin our next session. And let's treat Barry with all the respect he deserves, okay? Barry. Carry on.
Yeah, I think I have to wait for people to sit down. Yes.
All right, he's not going to begin until we all sit down. Wow.
Okay, so if Dean was going to introduce me, he would say, this person needs no introduction.
We'll get no introduction.
We'll get what he deserves. Right? Which I think is.
This person deserves no introduction.
Deserves it. So I think that's right. So, okay, so I'm very grateful to everybody who's doing things. I think I understand a lot about differences. I mean, I especially appreciated Kadri's talk just now because I didn't really understand why she and I were arguing with each other so much when we agreed about so much. She's not back in the room yet, so she can't.
Yes, she is.
She is respond to this. But now I have a much better idea about why we're disagreeing so much, and I can guarantee this: we will continue to disagree. Okay, so I got interested in this issue, and the reason this conference happened, and I mentioned this at the beginning, is I got a nice Templeton grant. There was some money left over. I promised I would do a couple of conferences. We already had one on probability, and I got interested in an issue about free will, about which I didn't know that much, and started reading a little bit about it, and then realized that something else I was interested in, that basically I learned about and I've been working on. I learned about it from David Albert mostly, and I've been working on it, or here, and I've been working on it since then. That would seem to me to be the key to understanding what was going on with the reason we feel that there's some incompatibility between physics and what we learn that physics tells us about the world and our being able to act freely in it. Okay, so I'm going to try to formulate and tell you a bit about that. It's very closely connected to counterfactuals. And in the course of this also, I developed a theory, an account of counterfactuals, which also coincides with Kadri's to a degree, but it's a different account and disagrees on some sorts of examples. Her account actually comes from Jonathan, the account she likes comes from Jonathan Bennett, although she was telling me, I think correctly, Bennett didn't really understand his account. So Jerry, so working on it. So I agree with all that. Okay, so that's what the basic outline of this talk is. And we hope is that the enter doesn't get to change from. How does it change, Diego? Where's Diego?
Oh, doesn't work.
The enter doesn't change?
Oh, no, I think it's the, oh, it's not even the arrows. What the hell? All right, yeah, it's the arrows.
Okay,
Well, I had some slides. One is just to indicate that I was going to be engaged in what Conrad called subterfuge as well, but I think John sort of occupied that territory sufficiently. I may occupy more the territory of the James quote of, what did you say it was? A morass of confusion. Wasn't that you, John, or was it Peter?
James.
James. Morass. Yeah, was that a quote from Peter? Peter from. I thought it was a morass of confusion. A morass of invasion.
James is a morass of invasion. I just said causation is a morass that I.
Well, I just wanted to preempt the remark that my paper might be a morass of confusion, but we'll see. Yeah. Okay, so here's a quote. I'm not going to read it. We've been through Peter's discussion of it. This is a quote from Peter. I liked it very much because what he's doing is declaring what I think he absolutely sincerely believes, that there are these arguments that he's refined and formulated, the consequence argument and the rollback argument, and that these arguments demonstrate to him that physics, whether the fundamental dynamics is deterministic or indeterministic, there just can't be anything that he thinks of as free will in such a universe. But he's confident that there is free will. And so he leaves it as a mystery. And the way he ends this quote, I really like, because this is where I'm going to come back to what I want to say. So let me just read that part. He says, I find very attractive the suggestions that's been made by Chomsky, and Colin also says something like this, and that there's something about our biology, something about the ways of thinking that are hardwired into our brains that renders it impossible for us human beings to dispel the mystery of metaphysical freedom. I think something like this is right, except I don't think it's necessarily biology, or it's plays a component. It's sociology together with biology, and I don't think it's impossible. At least I hope it's not. Okay. And I'm going to try to do that. Okay, I also wanted to just say at the beginning, just so to put things on the table, that the basic approach I'm going to take, I was thinking about it beforehand, but I found ideas similar in a paper by Kian Dor, and a really interesting paper that I just didn't even know about, even though this guy I know about, I know well. In fact, I only think I saw a reference to it in Janan's book, but I know Carl Hofer well, but his paper is a beautiful paper about this. Goes back to the year 2000, I think, but basically his idea, without a lot of the stuff that I'm going to stick it into, because there's a lot of other consequences, is in Carl Hofer's paper. I think it's called Freedom from the Inside Out or something like that. And Janan, in her beautiful book, Freedom from Physics, or Freedom Physics Makes Us Free. I always think about it, freedom from physics, wanting to get away from physics. That's how physics makes us free. But a lot of these ideas are in her book, and Christian List has a similar approach to some of this. And then I discovered that Carlo also makes use of very much the same ideas, as you'll see here, and that some overlap with Kadri. There are also some important differences. We'll see. Okay. I talk so much during the question. I apologize, but I'm losing my voice. I think I'll just let you read the slide. I mean, you could be thankful for that.
It's your own fault.
My own fault. Almost everything is. That's good. God, he says it here. Okay. Okay, so everybody knows what compatibilism and what incompatibilism are. Here are my brief statements of it. Now, the consequence argument itself has been given numerous formulations. I'm going to look at it in one particular way. And I realized that the way I'm going to look at it is a way that struck me as a way that ought to have convinced me at the beginning, but it's not quite the way Peter looks at it. I think when Peter gave his talk here, he laid bare, I think, what was the underlying thought, the quote from Genet. And I hope to come back to that. So I just say this ahead of time, because I don't want Peter screaming out that saying that's not the consequence argument. I think it is the consequence argument, but it is a particular version of it that I want to formulate. Okay, the way I'm going to do it is like this. I'm going to suppose that there's some sense of can, which I can choose decisions. And then I'm going to use the consequence argument to show that it isn't what it does you no good. And so you might as well just say that there's no sense in which you can make decisions.
What's the last sentence?
It does you no good.
After that.
And so you might as well just have said at the very beginning, there's no sense in which I can make alternative decisions. You don't need any argument. Just stop. Determinism is true. One possible history of the world. There's no sense of can in which you can decide to do different things. You could start like that, but it seems to be a more interesting argument is to give somebody who wants to be a compatibilist to say, well, okay, maybe there's some sense of can you have in mind in which you can make alternative decisions. But I'm going to show you that given determinism, it does you no good. Okay, so that's the way I'm going to formulate the consequence argument. Okay, so here's the formulation, the way I'm doing it now. It's on 2 slides, so you may want to stop to think about it. It's all very familiar. I'm going to assume determinism. Determinism is a thesis about the dynamical laws. It says the dynamical laws are such for two-way determinism that given the state of the universe, it does make use of the notion of state of the universe. In classical mechanics, that just means the positions or relative positions and relative momentums of all the particles in the universe. Okay? And that is the total state. And the dynamical laws entail, I say statements about each of these, entail the state at any other time. Okay. I think there are little places where one might quibble or make words about it, but I don't think it'll make any difference to this discussion. Okay, I'm going to suppose that there's some time t, a moment, so t is the time of making the decision. Okay, sorry, t prime is a time of making the decision. That there's some time t, just a teeny bit before, such that A can choose to make one of 2 decisions, either raise his left hand or raise his right hand. Okay, that's the choices. And what's interesting to me is that decisions are important to us only to the extent that they can influence what will happen. So, you know, I'm on the elevator, I'm deciding, should I press this button or that button? Well, it's what I influence. And by influence, of course, I mean something in the neighborhood of causation. And normally causation and influence are identified with each other. There may be some circumstances in which we'll separate them, but I will think I decide to do one thing or the other, depending on what I think my decision will influence. If I want to go to the 3rd floor, I'll do one thing. If I want to go to the 2nd floor, I'll do another. Okay. Suppose I actually choose one of these things. I say to raise my left, you press the left button. Okay. Then if the location of my hands at the earlier time then if the location of my hands at the time that of my making my decision were raising my right hand, either I would have had to violate the laws, or the state of the world would have had them indifferent all the way back to the past. Okay, so that'll follow from determinism. Suppose I hope what I said was clear what I meant to say. Okay, so whatever one does, one will do one particular thing. If we consider what the other choice, one would have done the other choice. It looks like that would require either violating the laws or the past being different, or the history of the whole world being different. Okay, and this is an observation, for example, that David Lewis made when he wrote his paper on counterfactuals. He said, if determinism is true, then it would have to be the case that in a world in which the false antecedent to a counterfactual held would have to be a world which either there was some region in which the laws of the actual laws were violated, not the laws of that world, but the laws of the actual world were violated, or the whole history of the world would have been different, or a bit of both. Lewis actually opted for something like a bit of both of those things. Then the consequence argument continues by saying that, look, you can't influence the laws. Whatever I decide to do, it's not going to make any difference to dynamical laws, to F equals MA or Hamilton's laws, or whatever Schrodinger's laws, whatever the laws are. It's not going to, can't make any difference. I can't have any influence over that. And I think most people would say, that's right. Okay. If I had chosen what the thing I didn't choose, then the past would have been different all the way back to the beginning. So I would have had to have influence of the world in distant past. Now, most people hear that and they think, you got to be out of your mind. I mean, I can't now, oh my God, I got so drunk last night. I didn't, even though I was invited out by Dean. I widely didn't go. But if I did go and did get drunk, this is now counterfactual. I would regret it now, but there's nothing I could do to influence that. But whatever other bad things I did yesterday, nothing I can do to influence any of that. I think that's absolutely right. There's nothing that I care about, think about, or can know about that I can have any influence over. I'm going to give a more precise definition of influence in just a little while. So I can't have influence over the distant past. I can't have distance over the laws. The past and the laws entail what will happen in the future. So I can't influence the future. So even if I grant that there's some sense in which I can make different decisions, what good does it do me? Because I only want to make different decisions because I can influence the future. So this is my version of the consequence argument.
I will turn the microphone.
Is there a problem?
No, it's just like I will turn the microphone. So
yeah, can you do me another favor? Can you, since the clock is all screwed up, wave when I have about 15 minutes left.
15 minutes.
15 minutes left.
Of the end of your talk, or
no, as I'm going through my
question, or you will take the full up now,
as we go through the talk. Okay. So if determinism is true, then I can't influence the position of my hands in the future, even if I grant that there's some sense of which I can make those decisions. That's how I'm understanding the consequence argument. Okay. Now, my response to the consequence argument is going to be that I think it's a valid argument. When influence is understood in a particular way, if it's understood in a stronger way, I think it's an invalid argument. Maybe we'll get to that or not. But the way I want to understand influence is in terms of counterfactuals. What I want to say is this, that my decisions have influence over something if there's a counterfactual dependence between my alternative decisions. And
just making sure this works.
Yeah, it's working.
It's working?
Yes, it's on. It just needs to be closer.
Barry, yeah, just get it closer to you.
Okay. All right. Yeah.
Okay.
There is a technique of not lowering your voice again.
Let's see if I can get you taller.
Well, I can't do anything about that.
You haven't mastered it by a certain age.
There we go.
Okay, well, I hope it works okay. I work for everybody else. Okay, so there's a famous reply by David Lewis to Van Inwagen's argument. I think Peter said it was the best reply, though it doesn't work.
Yeah, I bet he did it right. That is, he actually got into the argument.
Oh, I see. Well, I hope you think I get into the argument too. I think also it was the best reply I saw. And I thought that Lewis's strategy was right. He just rejected the wrong premise, as you'll see. Okay. So the argument really has just three premises. Determinism, I don't want to reject that. I think that's going indeterministic does no good, but that's not a discussion we're getting into. I want to tell a story about that in a debate I got into with Robert Kane, who's famous to want to do indeterminism, but I'm not going to do it because it'll take away from my time. But maybe in questions I'll mention it. So the only other two premises is, can we influence the laws or can we influence the past? And of course, since both of those seem bananas when most people hear about it at first, you want to do it in such a way that if you're going to reject one of them, you're going to do it in such a way that you can explain why it is that most people think that's bananas and it really doesn't cause any problems. And so Lewis thought that about the laws. And he figured out a very clever thing to say about why it is that his account, because it doesn't mean what you might think at first. When someone says you can influence the laws, it means you can now decide to fly faster than the speed of light. He didn't mean that at all. What he meant was this in his account of counterfactuals. And I assume everybody here knows Lewis's account of counterfactuals. Good. I'm not going to drag us through my slides about that. Okay, what he assumed was that in evaluating counterfactuals, as Kadri explained clearly, is that you ask, gee, I want a world that's as similar to the actual world as possible in that it matches in perfect fact as much as possible and matches in conformity to the actual laws as much as possible. And he wanted to balance those two. And he thought that he figured out a recipe in which the balancing ended up leading to the asymmetry of counterfactual, the temporal asymmetry of counterfactuals that he thought existed. I agree with Kadri, he didn't get it right about that. But also it had this interesting consequence, that if I had decided, suppose I scratch my left ear, not my right ear, but if I had decided to scratch my right ear at that moment, I didn't. The fundamental laws of the universe and the precise microstate of the universe entail that I scratch the microstate, which realizes that scratching my left ear. So Lewis thought a law would have had to have been broken in evaluating that counterfactual, because in the closest or most similar worlds in his account would be a world in which, or the worlds in which, they match the actual world from the beginning of time up to a few moments before my scratching my ear. And then some neurons fire in my brain or something like that, and I ended up scratching the other ear. But for those neurons to fire in my brain would have had to be a little region of space-time in which the actual laws were violated. But while a law would have been broken, I would not, as we ordinarily understand, have broken a law. I couldn't have decided, here's what law I want to break. I'm now going to go and break that law. You see, that's not quite right either. But I certainly couldn't have flown faster than the speed of light. Okay, so here's Lewis's kind of counterfactuals. We decided we didn't need to do that. You all know these pictures. You know his famous example from Nixon, right? Nixon had pressed, rather gruesome, especially nowadays, to be thinking about this. But if Nixon had pressed the button, there would have been a nuclear holocaust. Luckily, he didn't press the button. I don't know, luck, but whatever, right? He didn't press the button. If determinism is true, then the fundamental state of the universe from the get-go and the dynamical laws entail that he wouldn't press the button. So had he pressed the button, there would have been in the closest counterfactual worlds, there would have been a region of space-time in which the actual laws were violated in this account. And from that moment on, the actual laws take over and everything goes as normal. And since all the nuclear devices were patched and so on, there would have been a nuclear holocaust. Okay. All right, just one quick remark, which I'm not going to get into much. Many of you know, and I'm very interested in this, that Lewis had a view about laws, which he called Humeanism. On Lewis's view, what the laws are of the world supervene on the whole history of the facts about the world. some people think, gee, so the laws don't have any modal oomph. They're not chains that are tying you down and make you do what you do. And so they think that maybe the way out of the free will thing is just to say, well, laws don't constrain. Now, I think in fact, laws do constrain when constraint is understood properly, but they don't constrain because they have this metaphysical oomph. Okay, they constrain for other reasons, and we can talk about that later. And on Lewis's Humean account, the laws constrain. Okay, up to a point, but his account of counterfactuals makes it the case that they can be violated in close worlds. I want to get rid of that feature of his account of counterfactuals, just as Kadri and Perry do, and Keandor and some other people as well. And I'll talk about my account in just a minute. Okay, but main point is that going Humean about the laws isn't going to help you with the free will issue. I'm not even sure if anybody literally argues that it would. It comes up. I think Janan talks about this as a possibility, and Helen Beebe, I think, is a little bit more enthusiastic as a possibility, but I don't know anybody who's really argued it. Right.
A lot of people have said that to me.
But a lot of people are wrong.
Yeah.
Talk to you. I'm sure
But
that's
I'm
true.
just testifying that I hear this just as frequently as you do.
Well, you can tell them that you've heard it from a thoroughgoing Humean that it ain't going to help.
Yeah, I've already told them that myself,
Good. And you're not a Humean, so why should they believe you?
but it wouldn't help.
Okay, but good. Okay, but yes, I know that's a widespread idea. It's totally red herring. Doesn't get you anywhere. Okay. Okay, so I like Lewis's strategy, but I think his reply fails because his account of counterfactuals is defective. Now, this is, I think, it was observed and where Kadri and I were very much on the same page. It just took me a lot longer to get there, I think, probably. Although I could have gotten there more quickly because I knew about the simple theory from the beginning. But it took me a long time to get there. In fact, I only got there fully about 2 weeks ago, a month ago. But I've been there maybe 20 years because I knew there were big problems. And the big problem with Lewis's account is this. Lewis was trying to do too much with his theory of counterfactuals. He wanted to give an account of what we're talking about as the times arrows earlier in the discussion. By times arrows, I mean the pervasive temporal asymmetries that we see all around us, like that my decisions can influence the future, but I can't have any influence over the past that I care about. That I can know much more about the past than I can about the future. Okay. That causation goes in one temporal direction. And that counterfactuals also seem to Lewis to have a temporal asymmetry, as they sort of do, because it's not thoroughgoing. Lewis sort of made it too extreme with his account because he wanted to get rid of what he called backtrackers by just segregating. That was another mistake I think he made. Okay, I think there's some, what I think of as backtracking counterfactuals that we want to count as true and need to for counterfactuals to do the work we want to do. Okay, so I think Lewis's account of counterfactuals are wrong. Now, I'm not going to go into details here, but I just want to recommend for people who are interested in this, where to go look to find it. So there's a really beautiful paper by Adam Elga, statistical mechanics and the temporal asymmetry of counterfactuals, I think. Because I can't mention this without actually doing a little bit of autobiography. I just can't help it, though I might regret later. David, who's here, I think he will agree with what I'm about to say. I don't think he knew David Lewis from Genghis Khan until he met me. Maybe.
Yeah, I think that's right.
And I was telling you about David Lewis and all the great things he did in philosophy, including his theory about counterfactuals. And David said to me, that can't be right. Why? Because David is very, very attuned to statistical mechanics and thermodynamics. And he realized that Lewis' account of counterfactuals depended on getting his notion of temporal asymmetry. He thought that temporal asymmetry came from the fact that convergence miracles were going to be much more difficult than divergence miracles, and that's going to give rise to asymmetry. But David pointed out that miracles have nothing to do with it. You can get rid of the miracles. It's the asymmetry that's built into thermodynamics that comes from statistical mechanics. Okay, this is what Adam points out in his paper. So I think I knew about this before I read Adam's paper, but Adam just explains it in a very, very beautiful way. I think his paper is from about 2006 or something like that. 2001. 2001. So it's okay. So I just recommend it. I'm not going to go explain why that's so, but it turns out Lewis's whole account of factuals crashes and burns on this point, because it turns out Lewis thought that if Nixon had pressed the button, there wouldn't have been a nuclear holocaust. Wrong, because there are worlds that are, by Lewis's accounts, as close as could be to the actual world, which is one little region of miracle, and as much perfect match, maybe even more, in which Nixon presses the button. But by a little miracle, that world ends up matching the actual world from a few moments afterwards, and then goes on just as the actual world, no Holocaust. Of course, the past of that world is going to be very different. And that's true. I'll come back to that point about how you might, if you wanted to save Lewis, you could prepare his account. I don't think there's much reason to do that, but you could prepare his account by just adding something. Okay, so here's another thing about Lewis. I think miracles are bad. Here, Kadri and Kian and I are totally on the same page. Here's one reason I think is bad. Now, I thought I took this idea from Kadri, but she told me it's from Kian Dor. So I don't think he puts it in quite the way I did it. Just think about this now. Suppose I had scratched my right ear. Remember, I had scratched my left ear. The fundamental dynamical laws of the universe would have had to be false for a little region of time. In our universe, under most understandings of classical mechanics or quantum mechanics, there is, in a sense, just one independent dynamical law, either Hamilton's equations, perfectly time reversible, or Schrodinger's law. Okay, there are other versions of quantum mechanics, which isn't true, but think about these. That means that this dynamical law would have had to be false, maybe just for a little region of time. Well, if it took was for me to scratch my other ear, then it also would have been true that had I had scratched my other ear, I would have deserved a Nobel Prize, right? I don't know what I'd get the Nobel Prize in, maybe an ear scratching, but it's, but I would have demonstrated the falsity of the central equation of quantum mechanics. So that's bad on Lewis's account. So I want to have a different account of factuals. I have 15 more minutes. I better get but I'm in charge.
Wait a minute. I thought I was in charge.
Oh, okay. There's a really bad reason for thinking we can't influence the past. This is connected to a way in which Kadri sometimes put things about changing the past. I don't think you can change the past. How could you change the past? I don't think you can change the future either. How can you change the future? The future is the future. You can't change it. Past is the past. You can't change it. What you can do is influence one or the other. Okay. I think we can influence the future in an interesting, important way. It's like which floor the elevator goes to. I don't think I can influence the past, even if determinism is true and where I make different decisions. Now, why is that? So everybody get why it would be a bad reason to think I can't influence the past, just so that I can't change the past. Of course I can. And some of them might think I can't add to the past. I'm not sure what add to means here. There'll be a sense in which I'm going to say, there's a certain sense you can add to the past. Nobody could possibly call me. Good. Another bad reason is some might think it's a very fundamental feature of time itself. Okay, again, I want to reject this, but I'm not going to go into it. So Tim Maudlin thinks that time, by its very nature, flows in a certain direction. It's just part of the very nature of the dimension time to do that. And that's going to be the account of why you can't influence the past in any way at all, or change the past or do anything about that. But that's not going to be my reason. I think it's a bad reason. That's just bad metaphysics. Okay, or anyway, it's a big argument about that. Okay, so there is, though, an account of counterfactuals that I started constructing when I learned from David about statistical mechanics. And, you know, David was really good at teaching me about statistical mechanics. I think what I'm especially good at is making wisecracks. I hope you've noticed that. And thinking of names of things. And so maybe one or two other things, but at any rate, so this, if you take statistical mechanics seriously in a certain way, which not everybody who knows about statistical mechanics really wants to go along with, but I'm going to tell you the way, you end up with this. You end up with statistical mechanics can be accounted for with three basic axioms. I don't need to explain why people invented statistical mechanics. I will say a word about it. In the 19th century, people wanted to wonder, why is it that the world has asymmetric macroscopic processes like smoke always spreading and not congealing and going back? Why is it that people grow old, young? Why is it that ice melts and so on? And these are the laws of thermodynamics. They were temporally asymmetric, but the fundamental dynamical laws, as we talked about before, are temporally symmetric. So we know, where does that come from? And here was the suggestion Boltzmann came up with. He said, well, look, all of matter is made up of a lot of little particles. Not everybody held this idea, but Boltzmann and Maxwell put it on the table. And so I told you about it, it became pretty widespread, at least after about 20 or 30 years, by Einstein. Einstein sort of put the clincher into this, all matter is made up out of little particles, or at least at some level of description. They're all moving around like crazy, banging into each other. And Boltzmann thought there's a certain probabilities that the particles would be having certain momentums and positions with respect to each other. And when the particles have certain positions and momentum, that would realize an ice cube sitting in warm water of a certain size at certain temperatures. So the macroscopic properties supervene on the microscopic properties. Many, infinitely many microscopic states realize a given macroscopic state. And it turns out that given a certain probability distribution, the simplest one you can think of, it implies that over time, if you had an ice cube sitting in warm water, over time, it would melt. That the particles are most likely to be moving around in such a way. When I say would, it's a probabilistic would. It's very, very likely that it would melt. Very, very likely that it would melt because of the probability that the particles will melt when it's the macroscopic state is ice cube sitting in warm water is just about 1. And in fact, you can assign probabilities to how long it take it to melt and so on. Okay. Boltzmann's account left out something which he was aware of or made aware of, which took a long struggle for people to really figure out what they had. I think Eddington stated it at one point, and then Feynman does. And I think another person who's good at giving names is David. So he called this the past hypothesis, which is a claim about the very early universe. And that is that the very early universe has very, very low entropy. I think, at least among a big class of cosmologists, this is widely thought to be true. There are some philosophers who don't think it's true. There's even one philosopher who wrote a paper says it's not even false. That's worse than not being true, because it is. But his reasons were not good. I mean, it's a complicated story. So this is a claim I think you can make a good case for, that the entropy of the early universe was very, 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 very tiny. Okay. So here are 3 assumptions: fundamental dynamical laws, specification of the early macro state of the universe as having very low entropy. Maybe you want to add a few other things to that. Sure. And a certain probability distribution. It's what's called the Lebesgue measure of probability distribution, which is what we think of as a uniform probability distribution. And why believe this is true about our universe? Well, because it accounts for why it is that smoke disperses, why it is that ice melts, and billions and billions of other macroscopic phenomena in our universe. In fact, my view is it accounts for everything. So, like I said, I'm good at giving names. Well, it wasn't my name. I just happened to see a great movie by the Coen brothers I'm also going to take an extra minute to tell the story about this. The movie is Serious Man, which some of you probably have seen. And in this movie, there's a minor character who is scribbling in a book. He's clearly out of his mind. And somebody asks him, what's your book? And he says, it's the Mentaculus. And the person says, well, what is that? And he says, it's a probability map of the universe. We'll see in a minute that the 3 ingredients I gave you before provide probabilities over all microscopic, over everything in our universe, all conditional probabilities for any pair of macroscopic statements or microscopic statements for that matter. Just in the microscopic ones, if they're literally full states, we'll get probability negligible. So why believe it's true? Well, I think there's a lot of scientific reasons to believe it's true, but scientific reasons is not logical proof. What did Peter say, Lewis said? It's not Gettier, it's not Gödel, but it's very good. I think it's very good scientific evidence, and I think there are people in this room I know have been involved in demonstrating that. Here's a picture of how the microstates of the universe evolve according to the Mentaculus. There's an actual microscopic history of the world. The microscopic histories are illustrated by the very thin lines. One of these is the actual microhistory. Okay, but if we just start with the macroscopic history of the world, then the macroscopic dynamics will not be deterministic. It'll be indeterministic. I think this is really important. I don't want to go into a side issue about why I think this is important in Kadri's talk too, but maybe in discussions this will come up also. So macroscopically, the world is indeterministic, as we all believe, right? Okay, but microscopically, which is what the fundamental dynamical laws have to do, it's not. It's deterministic according to what we think the fundamental laws are. Okay, so here's the counterfactuals now. It's pretty simple, but I got to say one other thing about counterfactuals, and this is going to be related to something about Kadri's talk, and we're not going to get into an argument right now. I think that not only are backwards counterfactuals indeterminate, if you think about counterfactuals Lewis's way, but I think that forward counterfactuals are indeterminate too. Now, there's a paper that's been kicking around the philosophy world for the last 20 years or so by Al Hayek. It's now grown to be about 120 pages long. He's written other papers about this too. It's called All, and now we change it to Most Counterfactuals Are False, or probably false. But what he has in mind is this. He, like any good philosopher, wanted to take what physics tells us about the world seriously. And so he realized that, look, if I were to bounce a ball on the floor, physics tells me that there's a small probability, even in statistical mechanics, that the ball would go through the floor. In fact, even a small probability that the ball would get up and start imitating Peter Van Inwagen. There are so many fundamental dynamical, so many microscopic states that realize that, like infinitely many that really, continually many that realize that macro state, that, there'll be enough of them to do these weirdo things. Of course, their probability or the measure of the set of them will be negligible. So we don't have to worry if I bounce a ball about the ball doing the things I just mentioned. Okay, so I think all counterfactuals need to get a probabilistic qualification if we want to be serious about the physics. That's not to say we're going to, the next time you hear somebody say a counterfactual, you wave your finger at them and say, no, 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 no. Because of course we can figure out, why it's reasonable to say, if I bounced the ball, it would have bounced. If I dropped the ball, it would have bounced. Why that's okay to say, even though there's this negligible probability. But what I do think this shows is that we don't want to have exactly Lewis's way of thinking about counterfactuals in terms of a similarity metric. We want to go probabilistic full tilt. This is one of the things I also want to say about many of the talks that have gone on here. And that is, I think that taking the fact that the world is probabilistic, I think I read, you didn't think about probabilities the way I do, but there's a great quote, I just can't do it by heart, from Charles Sanders Peirce, who says something like, one of the great discoveries of the world, this is before quantum mechanics even, that there's probabilities everywhere. I think this is right, that the world is probabilistic through and through. And we got to take this seriously. And I think the probabilities all come from either statistical mechanics or from quantum mechanics. And if they come from quantum mechanics, there's a way of sticking quantum mechanics and statistical mechanics together. So it's still basically just one source. Okay, so here's an account of counterfactuals. I'm not going to have time to really defend it, but I'm just going to tell it to you. It's that if A had been the case, A pertains to time t, then B would have been the case, then the probability that B would have been X is true, just in case there's a time T star that's between the time of the past hypothesis and the time T that A pertains to. When the macro state of the world at that time was such that the probability of B holding that A will be true, it's will from that time, and that macro state holding is X. And that T star is a time closest between T and the past hypothesis for which this is a sufficiently large probability. It's not negligible. Now, I think that's context dependent, how much you want to make, how high you make that probability. This account allows for a certain amount of backtracking, but it doesn't go backtracking, go crazy. It allows for backtracking with counterfactuals that are precise, give you precise probabilities, even when they're not literally nomological. That's just a difference between the accounts, not arguing that one's better than the other. Okay. Now we're now to the punchline. With respect to decisions, the account of counterfactuals I just gave can be very much simplified because, of course, the time that you have to go back from decisions when we're really thinking in the context of freely made decisions is a very, very short time before the time of making a decision. In fact, I think we often have the idea that free will is such that even if everything about me says I'm going to choose red wine rather than grape juice or something like that, because of my past history, I could freely choose to make grape juice. I think that's how we often think about free will. If I evaluate the counterfactual like that, then I would say that it's just a very small difference in my brain that's going to be basically in the same macroscopic state of the universe if we divide macroscopic states up crudely enough. And it'll be a different one, depending on which decision I make, different neurons firing different microscopic states. But the probabilities towards one temporal direction will be very different from the probabilities of what will happen in the other temporal direction. What will be for sure is that it'll be true that the probability that the past was different, if I consider the possibility I didn't choose, that'll be 1. Okay, but it'll be just the microscopic past that'll be different. Nothing about the macroscopic past. The probabilities of anything in the macroscopic past would be any different. The future isn't like that. And here's where the asymmetry comes from. It turns out that our world is such because of the way the dynamics works, the way we divide up macroscopic states and so on, that very small differences between microscopic states can be enlarged by the dynamics to very, very big differences towards the one temporal direction, but not in the other temporal direction. Or rather, I should probabilify what I just said. It's really probabilistic. It's very likely to go one way, not the other. We all know this from famous examples that people say, things that nobody ever would have thought about, whether a butterfly flaps his wings or not in equatorial Africa will make a difference to whether or not Trump runs for election. Well, I don't know how Trump makes decisions, so maybe that's not an example, but you know what I have in mind, right? Okay, and this is true. Sometimes people call this chaos, and chaos is an example of this kind of thing. That very small differences can make for a big difference in one temporal direction, but not in the other. I'm not saying it can't in the other direction. I'm saying the probabilities are very, very different in the directions. That's a consequence of the Mentaculus probability distribution. Okay, so my account of counterfactuals that I just gave has some interesting features. Here they are on this slide. I'm not going to use this talk to advertise my account of counterfactuals, but I am interested in, because I just really formulated it recently, getting criticism about it to see, what needs to be fixed up in it. But this is basically it. And this is some features: no miracles, unlike Lewis, no similarity. You don't need similarity in the account I gave. There's no attempt to get the asymmetry, the temporal arrows out of the account of counterfactuals. Rather, the temporal arrows, so to speak, gotten out of the Mentaculus probabilities, and those are used to give an account of counterfactuals, which then have the consequence that you can only influence things in one temporal direction rather than the other, and it'll give the other asymmetries that are the right ones you want to get, not ones Lewis thought which aren't exactly right. Okay, so here's the bottom line. Our influence over the past is totally insignificant, because we influence over the past by the different decisions we can make is only selecting among different microstates of the world. And whichever one I take, the probability of anything macroscopic in the past, like whether there are pyramids in Egypt or whether Atlantis existed or not, those probabilities would be exactly the same. What will be different is the probability that the microhistory of the world would have been different. Of course, you can't avoid that. That's what we learned about counterfactuals. Something got to give if determinism is true. Okay. But we never noticed this. We don't care about it. And I think this is led because of, not that because nobody ever explicitly evaluated counterfactuals by this recipe. Of course not. I would have had to work hard to think up the recipe. I just would have introspected. No, I didn't do it like that. I was looking for an account, given the physics of our world, which would make sense of counterfactuals such that they're the counterfactuals that we need in the sciences and that pretty much match what people would, when they're informed about the world, think about counterfactuals. That's what I think this account gave. It has this interesting feature, that it has the feature that our alternative decisions don't influence the past in any way we care about or can know about. They can influence the future in ways we do care and can learn and can know about from experience. And so we've come to think that we can have no influence over the past at all. And that's led us to think that we can't add to the past, as Janae nicely put it. But I think we can add to the past. I think the view that we can't add to the past really comes from just about done. It really comes from a certain view about how to think about laws and how to think about time that people grew up with. Some of that just comes from what it's like to be an agent in the world, because an agent in the world, we don't want to make decisions in one temporal direction. Doesn't do us any good because we can't do anything any influence about things in the past that we care about. It also comes from a way of thinking about laws, that laws kind of like grip you and make you do certain things. I think that's a mistaken view about laws. Two, I do think that constraint, to the extent there is, comes from the way we evaluate counterfactuals, and that's built into the account of counterfactuals I gave. We think we can't influence the laws. Now, why laws are like that, that's a very, very long story, which I'm not going to get into, but that is something that there's a story about. Why it is that if you understand Lewis's way of doing counterfactuals right, you'll end up with that view, even though Lewis didn't end up in that place. So I think what I've done then is to do something of the sort that Peter was asking for. Now, do I think I'm going to convince Peter? But I do think I've done what he asked, and that is to try to give an explanation about why it is that we're hardwired in such a way that even when we learn about what our world is really like, we will then look our eyes and say, yeah, but determinism is true. And so if I decide to lift my left hand, and the world was like that in the distant past, such that it and the laws entailed that I lift my left hand, I could do no other. And I think that's because we have this sort of views that we grew up with. I think what we need to do is to realize that the notion of can that's operative when we think about decisions is the notion of what's possible given the macroscopic state of the universe at that time. And of course, there'll be many, many microstates, including many of them that correspond to alternative decisions that are correspondent. And that's the notion of candidate buildings. Okay, so thanks.
Oliver, Janan, Kadri, I was looking where your finger was pointing. We'll start with Janan and Kadri and Barry, what's our goal here for ending?
When people are hungry.
Too soon.
Well, when is that?
That's not.
That's now,
So what's the
yes.
actual time now?
Time now is 12:37.
Oh, so they're not gonna give us the lunch to one. We start end at 1:15 or 1:20.
Okay, so we'll end at 1:15.
We have 2 hours for lunch.
Oh, okay, great. Okay. So,
Super quick question. First, thank you for the paper. Why do you do things in terms of counting?
You might have to shout to me.
Sorry.
Because my voice may fall off, but yours begins.
Good?
Yeah.
Okay. Why do you do things in terms of counterfactuals at all? So why not just do things in terms of hypotheticals? You give a physical model of an agent and you say, you know, the agent, and you give an account, well, forget that. Why do you not just say, what we're really interested in for purposes of agency is the features of our world that we can kind of harness as strategic routes for that ends in a world with a thermodynamic gradient and effectively classical laws. What's that going to look like? Well, the agent should fix the macro state and ask what given the macro state of the world, would acting thus and so in the here and now, how would, what would happen holding fix the macro state? In what can I infer from that in the future, and what can I infer from that in the past? And it's gonna, everything that you said is gonna follow. Nothing in the past is gonna vary with it, but stuff in the future. You don't have to get into counterfactuals at all. Those hypotheticals are clearly defined without some special semantics in terms of the physical law.
So there's an autobiographical answer and a more serious answer. The autobiographical answer is because from graduate school, I was very interested in counterfactuals. I wrote about counterfactuals where we started, got very enamored of Lewis thinking about things, realized the things I didn't think were quite right about it. And so I wanted to see to what extent I could hold on to a lot of rules. This is the autobiography.
Yeah, that I
Okay. The other thing that's a little more serious is I'm not 100% sure about how you're thinking about hypotheticals. If you're thinking about the hypotheticals, those correspond to indicative conditionals.
So the hypotheticals are things that can be connected directly to a physical theory. So they're things like what would happen in a situation like this, and where the situation is specified by saying I fixed the macro. And you think of that as what.
Well, I think that's what I'm doing here.
That's right.
And I'm thinking, I'm giving account that this is the way we should think about counterfactuals. So maybe this is what I had in mind when I said more serious answer. My more serious answer is going to stick my neck out, which I'm glad to do if it gets chopped off because I feel through it. But what you just said is, yeah, I am. This is basically thinking in terms of hypotheticals. It's basically translating counterfactuals into hypotheticals. That's
So,
what
but
we're
here's the
doing.
proposal, right? For all of the reasons that you said, kind of philosophy got to thinking about modality in terms of counterfactuals, but think of a scientist. And then it got like sort of absorbed in intuition.
Yeah, but look, I want to publish this in a philosophy journal.
But just the proposal is maybe we should stop thinking in terms of counterfactuals. So the historical story is the one that you told. Like we started thinking in terms of counterfactuals because of the Lewisian tradition. Think about a scientist, and then we got really interested in these questions about, well, the data for semantics of counterfactuals. We test people's intuitions, and then we tried to sort of formulate that gets those right. Now scientists, when they're in the lab and they're like wondering, how do I design a bridge, or how, what would happen, they're assessing all of these modal claims. And they seem like perfectly factual questions. And the semantics of counterfactuals which seems completely divorced from the kinds of
Well,
factual questions you're asking. So a
Yes,
new scientific foundation for modality should forget about counterfactual.
maybe that's a good way to go.
Yeah.
And maybe I'll say that's, I've learned to go that way from you. And maybe that would free me up. But I have two other things to say. One is, one of the things you said is stop thinking. Very good advice. But it brings to mind a great photograph I have. And who told me? John Perry, I think. Is it John Perry who's not mentioned earlier? Or Peter? Something about Jakob. So Jakob Hindig was a philosopher no one here has ever heard of. He was very famous earlier. He was my dissertation director. And I was once taking him on a tour of Charleston. And he saw a sign which said, "Stop thinking of parking here." And he got so excited by it that he wanted me to take a photo, which I still have. I mean, he's deceased, so this photo's left as a record of him sitting in front of the sign, but you couldn't see of the words of parking here. All you could see is "stop thinking." So I hadn't thought about that till you just mentioned that. It just shows you how screwed up a brain can get. But yeah, I think that's an interesting suggestion. The sticking my neck out parts has to do with a question Kadri asked me last night. Is how does this account connect up with indicative conditionals? And all I thought about indicative conditionals, I just haven't thought that through. But I do think that I've brought my account much closer to indicative, the way people think about indicative conditionals. And I think it was a mistake to make that big separation. I'm not 100% sure that that's right, but I want to investigate that. So that's the sticking my neck out part, because I thought indicative conditionals are much closer to what you're thinking was hypotheticals. But I see why you were saying that wasn't really connecting with that issue. But you know, my history is such that I still want to connect that with the counterfactual.
So Kadri, then Tony, then we'll go online to Jacob and Ryan, and then we'll come back for Philip and Philip Swenson. We'll see how we're doing. Anybody I missed? Yes. What? Oh, yes, the finger that was pointing away. Yeah, so no, you're in there. You should be in there earlier, so I'll insert you. Okay, Kadri.
Okay, so my question connects up directly with Jen Ann's and your response. I understand why you want counterfactuals, and you know, you wanted to say something about the consequence arguments in terms of counterfactuals, and you want to preserve the connection with causation. But I want to ask, this is not the question I asked you last night, it's slightly different. So their indicatives and counterfactuals come apart, right? You're not a conspiracy theorist, Oswald didn't kill Kennedy, somebody else did, probably don't. If we're unless we're conspiracy theorists, that if Oswald had Kennedy, nobody else would have. I mean, your account is committed to playing those, but
Jeanette talks this quietly, you talk too fast.
like short time. There's an evidential asymmetry in the world, thermodynamics, and that's what you guys have been talking about. There's also a causal asymmetry. So one way of asking how the two might come apart is to ask a question of, becomes a problem. The predictor can be a mentaculus predictor. So last night we were challenging the possibility of such a predictor, but predictor has a mentaculus probability map of the world, and it knows that it's highly probable, say, that one boxer or two boxer. So if you reason, seems to me that if you reason in terms of your probability conditionals, which you emphasize don't involve similarity worlds, you should be a one boxer. But somebody who's a causal decision theorist will, for reasons that have been given by Lewis and others, so two boxers. But I think
So let's see, two things. One is I've learned from experience that when people bring up Newcomb's problem as a counterexample to some view, you say, wait a second, you know, it's a very, very peculiar situation to think about such a thing. But let's see if we can fit it in.
It gets us to precisely pulls apart.
Yes, no doubt. So it depends on which probabilities we want to use here. So let's see now, in this, does everybody know Newcomb's probability? Okay, so in this situation, I think that there's the macroscopic state of the world prior to my making the decision. It includes whatever there is about the world that might include records about decisions I've made in the past and so on, what the predictor has done in the past and so on. I think
All the philosophy papers you've
written about everything like that is going to be in this macroscopic state. When I conditionalize on that, I don't know what I'll get. Maybe I should have emphasized this about the Mentaculus. It is the probability of the map of the world. But although I have a very good GPS, Mentaculus has never shown up on my GPS, so I don't know it. But it tells me what I'm aiming for. These are the probabilities I'm aiming to have. In a discussion about what probability is. It's going. So here now I have all this information. It says that at this point, the probability that he will put, has he put the money in the box yet or not?
Yeah, the money is in the box, and we can add to this.
The money's in the box.
Well,
Is that part of the
either
macroscopic
there's a
state of the
million there,
universe?
or there's none there. We can run it either way, but it's there.
Right, but so that's the side. If that's in the macroscopic state, then the probability that I'm a two-boxer. Because if it's in the macroscopic
No,
state,
okay,
then the probability, then the
no, if it's in the one box, the probability is in the one box.
if you put the money in, right? That's
Yeah,
right.
yeah.
I was thinking the opposite. That's right. So if you put the money in, then what I ought to do is to choose that one box. That's right. Because the probabilities, the Mentaculus probabilities say that the probability that I'll get rich then is by just choosing one box.
And you know, all the arguments for saying that.
I see all those are now. I'm not in a position to sit here and even remember all those arguments, let alone show that they're flawed. But of course,
You could have the nun sitting on the other side with a mask on, so she has a poker face. She can see that the money is in there. She's saying, take 2 boxes, you'll be better off. The money won't go away.
but I know what that's in the Mentaculus. I listen to the Mentaculus.
See, I want to say, you're right, of course, you're gonna be rich, and I'm not, but I won't have regret.
Well, okay, isn't that doesn't that basically decide the issue? I could say, as Peter likes to end his papers, sue me, but now I'll be able to pay off.
But you see, we have 2 kinds of conditionals. Derivatives and counterfactuals. One way of resolving this is that.
Because I think we're conditionalizing on different things. So I think that is a difference. And I think even for counterfactuals, like for the Morgan investor counterfactuals, we have to conditionalize on different things. So those are counterfactuals, like you flip a coin and the coins landed heads, but I don't know anything about it. Later on, I say things like, gee, if I had bet on heads, I would have won. It looks like you want to say that that's true when said later. But if you go back to the prior time before the coin was flipped, you won't be able to say that. So for counterfactuals like that, you want to conditionalize on also this other information. So like when I said that the theory that I'm presenting here needs refinements, that's one of them. And I do think, and it's a good thing to do and a good thing for me to keep in mind. And so Newcomb's paradox is a good test example for me, is to just see how this separates the two out. But I think a lot of the standard examples of indicative conditionals, particularly future,
No, I agree, there's a lot.
will go totally together. And I think that's a good thing here. You don't have to be led to views like Dorothy Edgington had, that they don't have truth values and stuff like that, generally.
Barry, thanks. I really like this paper. There's one thing I'm puzzled about. You say toward the end that we have very little influence over the past or insignificant influence over the past. But there isn't, so I don't quite understand that. So here's a case. Peter's 1975 judge doesn't raise their hand. If they had raised their hand, so assume that this is the situation is the judge is working off good evidence. They're not making an intuitive judgment about that they could have gone either way. They're working on good evidence. So if they had gone the other way, then the world would be pretty different. You have to go fairly, have to say like 10 years back towards.
Wouldn't it, no,
Sorry,
wouldn't be pretty different. That's my whole point.
why would nothing be different?
Because that's what the Mentaculus probabilities are taking. Because the world is full of records such that those records encode, given those records, they give probabilities for what the world was like earlier. As long as there's a record of this earlier event, those will be the probabilities of this earlier event. And whatever decision you make, you're making a difference to those probabilities. So you'll have no influence over them. And I want to understand the counterfactuals in terms of these probabilities. Now, it is right, if you go back to understanding counterfactuals, just in terms of counting worlds, if there are no records, there are some worlds which would be very, very different, because there are no records. And this is something that this discussion got screwed up on early time, and there's an interchange involved me and David and Matthias Frisch, because we were thinking about influence over the past, not in terms of this probabilistic account of counterfactuals, but in terms of more like Lewis's account. And so it looked like, gee, suppose it was Atlantis. This is the example that's going in literature. Suppose it was Atlantis, but all traces of Atlantis have gone away out of the macroscopic world. But our microscopic history had Atlantis in it. Then it looks like you might have been led to say, if I'd scratched the other ear, Atlantis wouldn't have existed. Because the probability of Atlantis existing is so low. But I don't think that's the right thing to say. The right thing to say is you'd have no influence over whether Atlantis existed or not, because the probability of Atlantis existing or not is very, very low, no matter what you scratch or what decision. So you don't have any influence over, you don't have any influence over anything macroscopic. If that's not right, they're not the whole account.
Jacob.
Thanks. Can you all hear me?
Yes.
Great. Yeah, thanks. And Barry, that was a great talk. I have two questions. So first, if you could just, maybe I could summarize what I think I understood from your talk. Is it seems like your proposed improvement over Lewis's account of counterfactuals is that, whereas Lewis relies on local miracles, your approach is to, I guess, so to speak, thicken worlds from microstates into macrostates, along with including an appropriate probability distribution. And this goes back to the, initial macrostate of the universe.
Right.
Right. So we don't need to call for local miracles. Essentially, we're just calling for the consideration of a different micro trajectory within the same overall macro state. So we're not violating any physics.
Right.
So I guess where I'm a little bit confused is, and I've been confused with this for a long time. I'm confused about the metaphysical status of this macro state and the metaphysical status of the probability distribution associated with it. I mean, one could say, I mean, one I guess defensible view is, look, there's only one actual microscopic trajectory. I mean, in the diagram you showed, that branching diagram, you had a little arrow pointing at like, this is the actual microscopic trajectory. It was just this vertical line. It didn't do any of the branching. So I guess the question is, what are your ontological commitments here? I think we're committed to the idea that there in fact is at least this actual microscopic trajectory. What about the rest of the trajectories, the micro trajectories within the larger macro state? What is their metaphysical status? Are they fundamental physical things? And if they're not, then what kind of force do they have that will let us escape the consequence argument? And I'll just say one quick provision to this. So I see Eddie is on the call, and I know that Eddie has proposed a potentially persuasive answer, which is we should think more quantum mechanically, and rather than talk about a mentaculus, we should talk about a wentaculus. That is, the density matrix is at least arguably an ontological thing on some views of quantum mechanics. So if we declare that we're going to replace the mentaculus with like a specific density matrix and give it a physical interpretation, I think that to some degree gets around this question. I'm not sure it does. I know Eddie's here, maybe he can explain, but conceivably it could, but without that, I guess I'm just a little unclear how metaphysically I guess, up in the air microstates that are not the actual macro state can let us get out of the consequence argument. So I'm hoping you can help explain.
Okay, so there's much more to say than I'm going to talk about now. But it'd be very helpful to me to interact by email with you. But I'll say a little bit. First thing is, I thought you were going to go in a slightly different direction at the beginning of the question. I thought you were going to ask, what's the ontological status of the probabilities and the laws in your account?
I also am confused about that as well, but I couldn't have done that because of my initial microstate. So my apologies.
Okay, so I'll forgive you in that case. But okay, so there's a lot to say about that. I won't even try to, but basically, I began this with the background of Lewis's view about how to think about probabilities, though Lewis didn't, I think, understand his own view quite right. And there are probabilities, given his view of probabilities compatible with determinism, given his view about probabilities, and I have that kind of view. So all there is, if I were to say what actually exists on this version of my view, all that actually exists is one damn thing after another in the actual world. End of story. That's all that actually exists. Okay, so that's not my really view now, because I want to get away from certain features of Lewis's view, but I don't want to go down that road now. It's a whole other discussion. The other question was, well, what about these other micro histories? What are their status? And I'm not sure I have a really satisfactory thing to say, but suppose I say, what would you think about this? Suppose I say I'm full Lewis for this. You know, I think that they're existing other worlds. They're concrete as this world. I don't know any arguments other than a stare that shows that that's a coherent view. Suppose I had that view. Would that satisfy your worry?
But do you think your view depends on that, Barry?
No. I just want, here's what I think. I think if I were to say what I like a little bit more is to just say there are ways the actual microstate could have been. But, you know, I'm not sure that's going to be a satisfactory answer.
I think it could conceivably satisfy my view. I suffer from the stare. but I think that because in that case you are actually adding something to the ontology, right? Otherwise it's just sort of all on our heads. It's hard to see.
Not adding to the ontology of the actual.
Yeah. Oh, it wouldn't be part of the ontology of the actual. Yes, right.
And I do think there's a line of thought that I don't think has been fully developed. I'm not sure that can make Lewis's view sound much more plausible than it seems at first. But like I said, it's a whole other discussion. But what about the other answer, that the other histories are just the ways the actual history could have been?
I'm not, I guess, quite sure about that. I'd have to think about it. But this is related to a very close related second question I had, which has been bothering me since yesterday. But I think it sort of rises to the fore from your talk. So people keep saying that our best understanding of physical theories today is that they're microscopically deterministic and time reversible, including quantum mechanics. And I guess I'm having a little bit of difficulty parsing what's meant by that. So, you know, obviously this can depend a little bit on which interpretation or theory of quantum mechanics you're using. But let's even say we pick something like the Everett approach, which, you know, proponents argue is time reversible and deterministic. It's deterministic at the wrong level for much of the discussion we're having. I mean,
why is that?
Well, so this, I'm gonna get to that. So, you know, we keep talking about ear scratching and assassinations and window panes breaking, but the Everett approach is deterministic about the wave function of the universe, and none of those events, ear scratches, glass breaking, any of that is present fundamentally in the Everett approach. it only sort of emerges on some appropriately coarse-grained choice of description. And it only emerges once you have indefinite outcomes, right? Like there's no, in the Everett approach, you don't emergently get the glass definitely breaking, right? The level where the glass and the brick and all that emerges, you have lots of seemingly, you have all the possible outcomes. And so there's just no level in something like the Everett interpretation where glass breaking happens deterministically, if that makes sense. And then of course, there are other interpretations of quantum theory that are just fundamentally indeterministic.
I mean, one question is whether glass breaking happens at all in the Everett interpretation.
Well, sure, right, exactly. To the extent that it happened, you're correct, right? But to the extent that one could argue that it's happening only at a level of sort of, high level, emergent level where it's not happening deterministically. So I'm very confused when people keep, because you said in your talk, and I know you were obviously being somewhat glib, if I scratched my ear, I violated quantum mechanics and I should get a Nobel Prize, but quantum mechanics wouldn't say that any of this, and the reason this is connected to my previous question, of course, is that if you take something like an Everettian view, which I'm not advocating here, but if you did, that does thicken your microscopic trajectories. It does mean that you have all these, they're not Lewisian possible worlds, but they're branches in which you have very different looking macro realities, in which there's one macro reality where you scratch your left ear, and there is a macro reality in which you scratch your right ear. So it seemingly is sort of a middle ground, potentially.
Yes, I understand what you're saying. The reason I asked you, where do you think the branching comes from that gives the asymmetry you're talking about, is I think I know the answer to that. Or maybe Carlo or David could help me out, but this is what I think I've learned, is that it comes from decoherence, of course. And where does decoherence come from? It's basically a thermodynamic phenomenon. And so you're going to have to introduce all of the apparatus of statistical mechanics in order to give an account of how there's decoherence in the world.
Agreed. Yeah. Okay. I think I'm agreeing with that. I'm not saying that this is a challenge to your view. I'm saying that precisely the opposite. You're looking for, potentially some, greater physical meaning to the other possibilities. And these, again, aren't Lewisian, this isn't a Lewisian view of those possible worlds being real. But there's still branches that are doing some of that possible work, filling out the rest of that semi-classical,
Right? He tries to interpret Lewis's notion of possible worlds all in terms of the branching of Everett worlds.
Right, and it's possible the branches are playing the role of the other microscopic trajectories within the macro states.
Right. So far as I can see that other than the way I set things up, it doesn't really affect the whole spiel about how to think about these conditionals and influence. Or does it? Do you think it does?
I'm not sure. I think maybe it doesn't, but I'm not totally sure. I also don't want to dominate the discussion either. So, but thanks. This was very helpful.
Okay, Carlo had a finger on this, but we've got 4 people and about.
Barry has already said.
Okay, good, perfect. So we got 12 minutes roughly. Peter, you're next.
Okay, I don't really have time to talk about what I think is the philosophically important stuff that we're disagreeing about. I just want to say one thing, maybe we'll get it later. I just want to say one thing about what you said about Lewis's account of counterfactuals. There's 2 things you can mean by Lewis's account of counterfactuals. There's one that the implications that semantics have for logic, and the other that it has for truth and falsity. If you don't say anything about what the closeness relation between worlds is, that's enough for logic. You just have to have the relation. With the one single exception, you have to decide whether you have weak centering or strong centering. I think that's perfectly right in Lewis. That is, the logic is right. But I agree with you, when he starts to say what closeness amounts to in terms of overall similarity between worlds and small miracles and so on, yeah, that's all screwy. So I just don't want to lose the baby of the logic when we throw out the bathwater of the analysis of closeness.
I understand what you're saying. I was talking, of course, about the second.
Yes, I know. I just wanted to make sure that.
And as far as the baby is concerned, if I could say for myself, I actually played a little bit of a role in nursing the baby because a paper I wrote, which nobody's ever read, but it's in Journal of Philosophical Logic, when I was in graduate school actually, is an argument that you got to have the similarity semantics in order to get the logical principles. We'll go sort of in the opposite direction. Really. Nobody's read the paper, so I'm not.
That just seems to me logically wrong, that you can prove all the theorems with just an unspecified closeness relation, but
No, you
I'll
need
have to
you
see
need-
your paper.
You need to get this, you need to have a similar, you need to have transitivity. And I mean, it depends which things you're building as the theorems. Okay, but yeah, I'd love it. You know, if you have,
Okay,
yeah, it's like
Yeah, I
7
agree, you have to say
citations
some
on Google's.
you have
I'll
to
see
say
what's
some
going to
formal
get an
things about closeness that you could just read off spatial closeness.
It depends how much you want to build on the logic.
Yeah, okay.
Okay.
That's all I
However,
wanted to
I
say.
now think that that's wrong too.
Oh.
So I want to fill the baby out. You know, I don't know how far I want to go. I wouldn't go with the Supreme Court.
Well, you know,
decision.
as Jerry Motor said, it's one thing to throw the baby out with the bathwater. It's the other thing to throw out the tub and the toilet and the floor of the bathroom.
Who knows what your bathroom's gonna look like?
Let's go online to Ryan.
Hi there. Hopefully you guys can hear me.
Yes.
Okay, great. Thanks for the talk, Barry. Really enjoyed it. I had a question about, I worry about a certain prediction of the counterfactual account that you offer. And so I want to ask if that prediction is actually right, and then depending what you think about it. But I'm specifically thinking about, you know, if we get further and further away from the past hypothesis, from that initial state, you know, get all the way to like entropy equilibrium, something like that. And then eventually we get like Boltzmann brains forming at super unlikely places. And I'm thinking about Boltzmann brains making decisions. And it seems to me that on your account of counterfactuals, the Boltzmann brains could have influence on their past. Namely, if they made any decision whatsoever, or any other decision whatsoever, their lives would be shorter, because it'd just be more likely that you know, they gradually formed out of the you know, entropic soup right as they were making that decision, as opposed to like sort of like existing for a bit of time and then making a decision. So I worry that the counterfactual account suggests that these Boltzmann brains can influence their pasts such that they shorten them, that they came to be sooner rather than, or closer to their decision rather than earlier than it. And so I wonder what you think. Is that a true prediction or a prediction of your account? And if so, what do you think of it?
Is a prediction of the account. Of course, the account isn't made to apply for Boltzmann brains, but I'm not sure it would shorten their lives. They don't have long to live anyway. I mean, I'm not sure it makes a difference. So how, you know, they'll disappear right away. So
yeah, so maybe maybe it's not an issue that Boltzmann brains can act such that their pasts are different in very like significant ways. Is that the suggestion then?
Well, there'll be probabilistic dependence, these different decisions, but using a uniform distribution, and you don't have anything like any constraint on it that is asymmetric. There'll be no asymmetric probabilities either. So whatever influence, they'll have one way, they'll have the other way.
Okay. Well, thanks.
It's not meant for Boltzmann brains.
Sure. Okay. Thanks. Appreciate it.
So Philip, and then Philip Swenson, and then we'll see if we can get Eddie in as the last question.
My question has been answered.
Oh, splendid. Best kind of question. Philip.
Thanks. I had this is kind of similar to the Newcomb question, but I was wondering about if there's a scientist in the past who looks at the microstate, and could he then do something differently? You know, so suppose he says, I'll look at all the microstates consistent with Philip raising his hand right now, and if one of those happens, I'll set off an explosion or something. Are you okay with, in that kind of case, me having control over the past? So if I had raised my hand, he would have seen a certain microstate in the past, and he would have set off an explosion. Does that follow from your view, and are you okay?
I'm not sure I fully understand what you're setting up here, but I don't think that it's possible for anybody to know the microstate. It's just not nomologically possible. Because human beings exist in the world and they'd have to have all the information about the microstate. Okay, I don't know if that's a sufficient answer.
Well, yeah, I think if that's impossible, then you could just say the case never did
Okay,
come up.
but it would be very interesting to think of examples in which this account has consequences that strike one as funny. I'm interested in finding those examples. And as we saw one, like the one that was just given about the ultimate brains, and I think it doesn't bother me. It's funny.
Eddie. Are you there, Eddie?
Yes, I am here. Can you hear me?
Hi, Eddie.
Hi, Barry. Thank you for your talk. Super interesting. I'm very much convinced by your response, at least in the context of classical mechanics. And I'm thinking about how to motivate or similar response to the quantum case. This related to what Jacob was asking earlier. So we probably had talked about this already, but I'm thinking about the case of strong determinism, where you have a simple law that determines a unique initial state of universe. So there's only one nomologically possible state or possible world given the laws of physics. In that case, if we plug in your response directly, it would be something like, I have influence over the past, but because of that, I'll have influence over the laws as well, because there's only one nomologically possible world. So I was wondering, given that kind of context, should we perhaps try to extend this account by thinking the counterfactuals a bit differently in the quantum case? Perhaps we can think of counterfactuals not involving entire worlds, but entire, say, subsystems of the universe or branches of a quantum state. In which case we say decision counterfactuals are counterfactuals involving branch relative states or subsystem relative states. So we can still get a semantics for hypotheticals, but not in terms of alternative states of the world, but alternative states of the subsystem or branches. That might still be in the same spirit of your response to consequence argument, but I'm not sure.
I don't see, but two things. I thought that Jacob was going to bring up when he mentioned the Mentaculus, I thought he was going to just bring up the point you brought up. In fact, the discussion didn't quite go that way. And I was going to then remind him about that you were a student of David and mine's here and say, you've got to be careful what you bring up. Turn on you later in life. But that's good. I mean, I do think thinking this through is very good and helpful. Now, if it turned out that the fundamental dynamics of our world only allows for one micro possible history of the world, you're going to have to do a lot of reworking because we still want to talk about macroscopic laws and stuff like that. And macroscopically, of course, it might be just one way microscopically things could go, but we don't really know what that is. So we're going to have some substitute for things like there'd be many, many ways of realizing, what it is for there to be an ice cube sitting in warm water. I'm not sure. So we'll have to recreate all of that. Once we've recreated all of that, and maybe we'll do it by just recreating statistical mechanics, or maybe some other way. I don't know. I think that'd be a really interesting question.
I see. That's helpful. I was thinking that suppose we keep the signs the same, statistical mechanics run in the same way, but we're changing the semantic counterfactuals in a way that might be a bit radical. We don't have to invoke entire worlds, but involve parts of the world as the truth matrix for counterfactuals.
Yeah. Right, I could see that would be a way. Or you'd give up on counterfactuals totally, but you're still going to need these hypotheticals, and you might just do what Janan was suggesting, just skip counterfactuals. I mean, the reason for not doing that, actually, I didn't say, but Kadri did say a little bit later, and that is that counterfactuals do seem to be tied to causation in a way, and we do want an account to count causation, and we want to connect that in some way to either counterfactuals, or maybe we just skip counterfactuals totally there too, and just go probabilistically full tilt. And that's a really interesting question. So there's some people who want to give an account of causation just in terms of probabilities and statistical mechanics, but I don't know any account that's satisfactory like that.
Some people want to give an account in terms of counterfactuals. I don't know any account that's fully satisfactory like that. So I think that it's still a work in progress.
I see. Thank you.
I had a finger on Eddie's question, if it's okay.
Janan was just had a finger on it as well.
Oh, go ahead. I'm sorry.
Yeah, very quickly. I mean, the interventionist analysis.
Oh, we can't hear you.
Oh,
Sorry.
sorry. The interventionist analysis of causation, which is really good at capturing most of kind of scientific activity under formal framework, is tailor-made to just do it in terms of intervention.
So I never understood how it extends to things like the meteorite hitting the Yucatan.
Let's talk.
Okay. Yeah, I think we have to stop and eat lunch, right, Barry? It's,
If we're hungry.
Yeah. Okay, thank you. Sorry for the good.
Yeah, it's good. I'm running off. Yeah, I think, I mean, I.
No, you object.
No, but actually I'm thinking of that, we should talk more. We should talk more about this, you know, about the metric free proposed. I'm confused, we should talk.
I tried to put that in the paper I'm writing and realized the thing I thought I was saying to me didn't say it. So I agree we should. talk about
Okay,
that.
let's talk about it.
Okay, and I'm not even sure now whether we're really